look at all the servers. So can anyone tell me what are the servers you built? Fanny, you build 9016. What was the IP address? 91? Raiden and Raiden, what is your server? Santosh, did you build a server?
No, Deepu, I did not build a server.
You didn't even try, no, not building. Did you try to do something?
I'll start from tomorrow, Deepu.
Okay. Raiden, did you try? So if the server is not up, you can always power it on, right? That's why you have ILO, correct, Raiden? There's a Java problem on this box. That's the reason this is not coming up. I can. That's fine. Hey, Arvind, what about Satya? I didn't see him.
Regarding what?
Satya, I don't see Satya here. Satya is there? We are missing Satya and Shrikar. Okay. Satya is there. Okay. So who is missing actually? We are missing Sridhar, right? And Bharan is also missing. Hey, Raiden, can you try to contact him, please?
He's not picking up this phone. I'll try to get in touch with him.
Okay, so guys, I have reboot. I have changed the password of all the 4 servers I know. Starting today, nobody will be able to connect to those servers and power on or power off or reboot or rebuild these servers. All these servers currently having ESXi 5.1, I believe. This was 95. So the reason I'm taking that rights from you is I think you all are done with the reboot, I mean, to the build. So there is no need to connect the servers, because if I give you the rights, what happens is somebody will reboot it or somebody will rebuild it, and I don't think we need to do that anymore. So we have the servers, and these are the servers. Let me just verify once again each one of them. So this is the first server, ESXi 5.1. The IP address is 95. It has some VMs. That's good. The second one is 91. That is also 5.1. It has some VMs. You can build more VMs there. The third one is 96. That is also 5.1 and some VMs. And the fourth one is 97. That has some VM. And then I have 2 more VMs, ESX servers here, which is this is 202, which is currently the one I was teaching, and then we have a 200 box. That is also my old VM. So we won't be using that one, but we will be using all these 5 servers. I have one more server. I just happened to see that it is showing some problem from the memory module, so I have to reboot or see what's the problem. That's a hardware problem. So hopefully we'll have 6 servers to the class, but 4 is good enough. We can play around with it. Maybe we will have one more server. So you will not have any more ILO access. Okay, I think everybody has tried enough. You know how to rebuild servers. You know how to build servers. So going forward, we're going to use these servers for all our lab, classes. Okay. So my goal here is to finish the storage portion if possible today. Let us see how far we can go. Okay, so we're still missing Sridhar and Byron, which is not good. Anybody has Sridhar's number? Aravind is saying you need to reboot. Why do you want to reboot? Okay, so forget it, Byron. If he is not there, we cannot help. Right? Sujan was there. Where is Sujan? Okay, we're missing more people. Let me call, guys. Hold on a second. IceKC today. How many of you are familiar with IceKC? How many of you have used IceKC? Okay, so IceKC is another protocol to access storage. We talked about or we learned about fiber channel protocol. We saw what it can do. We see the fiber channel components and stuff like that. So IceKC means Internet SCSI. SCSI is the small computer system and the standard SCSI protocol, but it is the standard SCSI protocol over the internet. That is actually it is using TCP/IP as its main protocol. So because TCP/IP, you can do long haul communication because you can have a storage in Australia presented to a server in New York. So that is what the IceKC can do. You can connect storages that are far apart using IceKC protocol. But fiber channel protocol is not possible to do that. It has some distance limitations. You can use up to like 50 miles and all with the help of some repeaters and all, but it is not recommended. Typically, fiber channel protocols are used within a data center, 10 meters, 15 meters, 20 or 100, that type of thing. It is not recommended for long haul traffic, So even with 50, 100 miles, you can use the fiber channel protocol with some repeaters and stuff like that, but it's not recommended. But with the help of IceKC, that limitation is over. It is becoming one of the most widely used protocol in the industry. It is very similar to fiber channel protocol. It is block-oriented protocol. So we're going to look into IceKC. So what is IceKC? This is what it is. It is a SCSI transport protocol. The protocol is actually a SCSI transport protocol enabling access to storage devices over the standard TCP/IP network. So the TCP/IP is definitely the protocol it is using in order to do the connections. And you can read the second line here, maps SCSI block-oriented storage over TCP/IP. So when it accesses storage or when you try to access a SCSI storage, the traffic or the communication is basically block-oriented. It will be accessing or reading it, writing it on a block by block basis, just like fiber channel. So that's what it is saying on the second line. So when it comes to iSCSI, there is something in it, so you don't need a fiber channel HBA, fiber channel HBA, the QLogic and MLX HBA is what we discussed. They are explicitly used for fiber optic connections, but when it comes to iSCSI, there are two pieces we need to talk about. Just imagine that picture what we discussed for fiber channel. The HBA in the place of HBAs, your servers should have something called as initiators. It is also sometimes people call it as iSCSI HBAs. We will talk about that in a minute, but normally the device or the hardware that you use at the source side is called as initiators, and at the storage layer side we call it as targets. So basically initiators and targets, these are the two things we need to look at when we talk about iSCSI storage. So basically these are some of the quick advantages of iSCSI. It is cost-wise, it is comparatively less expensive than fiber channel. Why it is less expensive? Because you can use your existing network infrastructure to access iSCSI, because it is TCP/IP. It can use your normal network cards, or you can use your existing networks, your Cisco switches and all, instead of fiber channel switches like like your Cisco MDS switches and all. Those switches are also costly, but you don't need to use any fiber channel switches. You can use your existing Ethernet switches to do the routing and things like that. So just because of that itself, you can make a huge saving when you are using iSCSI protocol. So cost-wise, it is much cheaper compared to fiber channel. Infrastructure, that is the second point. They're saying you can use your existing Cat5 wiring and Cat5 infrastructure using your switches and cables to do your connection. You don't need any fiber optic cable or anything. Routing, it is just the IP traffic, TCP/IP traffic, whatever the IP traffic is possible, you can do that. Long haul transfers, as I said, you can do geographically far apart storages. You can connect using long haul transfer. FCOE is a different technique, that is fiber channel over Ethernet. That is something that is now coming up, but again, FCOE means that is that doesn't mean that it's a different protocol. It is actually the fiber channel protocol transferred over the Ethernet, but it is still, the protocol is different. So FCOE is not this. This is totally TCP/IP. So how is iSCSI used with the ESX servers? It is again the same thing. You can use ESX server to boot from iSCSI, just like I discussed with fiber channel. You can use iSCSI to boot from the SAN storage, provided you have hardware initiators. So I told you initiators are something very similar to HBAs. They are called as iSCSI HBAs. So there are, when it comes to VMware, there are two types of initiators are there. One is called as the hardware initiators, and the other one is software initiators. VMware ESXi servers come with the software initiators, and that is what we will be using. It is highly, it is recommended to use for production. There is no reason not to use software iSCSI. You can use that. When you use software iSCSIs, you will be using your existing network cards for your iSCSI communication. Whereas if you want to use hardware initiators, they are something different. They are also very similar to network cards, but you have to buy that. That is a costly piece. If you want, you can use that. So you can actually see iSCSI HBA. So these are iSCSI HBAs. You can look at the picture. It is very similar to a network card. If you look at this picture, you can see that it is the network card itself. but it is a QLogic ISKC network, HBA. You see that? So this is called as an ISKC HBA. It is not the normal HBA. It is also called as, or you can say ISKC network card or something like that. It is network card because you are doing TCP/IP communication. So what I'm saying is you can buy these ISKC HBAs, or you can use your existing network cards on your servers itself with the help of VMware's provided software ISKC. Microsoft is also having the same thing. Microsoft R2 servers and all comes with the software, ISKC software, so you can actually use that also. So this is costly. I don't have this ISKC HBAs, but what they are saying here is if you want to boot your ESX server from ISKC, then you should have hardware initiatives. If you are using software ISKC and the existing network cards, you cannot boot ESX server. But other than that, you can do everything with software. So once you have a ISKC storage, you can format that with VMFS partition, and once it is just, formatted with VMFS, it is just like any other storage. It is like VMFS storage. Then you can create VMFS. You can put VM state, ISO files, templates, whatever you can do with Fiber Channel. The same things can be done with ISKC also. So all these things, vMotion, RDMs, you can put all these things. You can do everything. So nothing different. Anything you can do with Fiber Channel, you can do with ISKC also. Okay. Only difference is booting from ISKC requires a hardware initiative. So this is the components of an ISKC SAN. Now you are looking at it. We are talking about ISKC SAN here. So when you talk about ISKC SAN, it is the same concept. The storage array is again same. That's why I said, you buy EMC storage array or HP storage array, whether it is attached to whether it is having Fiber Channel adapters or whether it is having ISKC adapters, that is the only thing, and the protocols that you use is different. So basically all these concepts are still same. Even if you are using ISKC, you have to have a physical hard disk, you have to create LUNs, there will be storage processors and all those things. So that they are all going to be same. The difference is here. Instead of Fiber Channel switches or fabric, you're going to be using IP network here. We are using your existing IP network to connect. Now look at these two ESX servers here. In this two pictures, you can see that on the right hand side one, you can see that it is showing an initiator. It is saying software initiator. So in that case, you will be using the existing network cards with the help of a software initiator, which is called as a software ISKC initiator, which comes with the ESX server. We're going to look into that. Whereas on the left hand side one, there are two HBAs, but these are ISKC HBAs. They are the one I showed you in picture. You can put that and you can use that to connect. In that case, you don't need the software initiator or the software. You don't need that ISKC software. The software is inside this HBAs itself, so that it can be used along with ISKC product. So I don't think there is anything much to talk here. If you look at carefully, you know that it is very similar. Any questions anybody having on this picture? Any questions?
Deepu, nothing about this. Sorry, go ahead.
Correct.
Deepu, what do you use in your company? Do you use ISKC or Fiber Channel? And how
we don't use ISKC. We are in our company, it's 100% Fiber Channel. But I know Citibank, Goldman Sachs, and all started using ISKC. We may also, going forward, we may be considering to use ISKC for some of our environments. Again, when it comes to high performance, definitely we will be using Fiber Channel, because Fiber Channel is performance-wise, Fiber Channel is definitely better than that. So when you talk about, large financial companies, Fortune 100 companies, they don't care about the cost. For them, performance is at most important, so they don't care about it. So that's why I'm saying cost is the factor. If you have the cash or money, you can definitely go and buy fiber channel or InfiniBand technologies. But when cost is a factor, you may have to consider iSCSI. So iSCSI works well. There is absolutely no reason to it. But if you're asking me, which is better, fiber channel is definitely better.
And is the bandwidth difference huge?
No, it's not the bandwidth. It's not the bandwidth is the problem. The problem is with the performance. Actually, it's not the bandwidth an issue.
Okay.
Okay. So Sujan has come. I don't know. Okay.
Deepu?
Hey Sujan, can you hear me? Sujan, can you hear me? Okay.
Deepu, quick question.
Yep.
So presently in my organization, for almost 90% of the VMs, virtual machines, we use iSCSI instead of pass-through disks. Why is that?
Instead of?
Instead of pass-through disks or fiber channel storage.
Okay, you are using iSCSI, right?
For all the VMs, almost all the VMs use iSCSI.
Okay, are those VMs running Microsoft's critical front-end servers that is running Hotmail and things like that? Microsoft.com, no, right? They are used in what environment?
This is for the Microsoft internal IT, not front-end.
Right, it is for the internal IT. That means most of them are development machines and your own use, your own company use, where
Yes.
people are doing more developments and stuff like that, correct?
Yep.
That is why, because that brings them a huge amount of savings when it comes there. For the internal users, for the internal people, that they don't care about that high-end performance. So, and there is also probably, when you talk about Microsoft, it's a huge company with a huge environment. There is a lot of money is required. You're talking about millions of dollars are required if they wanted to put all your thousands of servers into fiber channels. So there is a big amount of cost is a factor. And probably that's what. I don't think there is any other reason. But that's what I'm saying. The performance when I talk about it, I'm talking from a financial perspective. When you talk about financial companies, the amount of processing, they don't care about anything. They need 99.99 uptime with the highest performance. I'm ready to pay even $100,000 more. Can you give me more performance? That is what they're asking. So for them, money is not at all a problem. They care more about performance. They care about the latest and latest technologies. But when it comes to Microsoft or when it comes to that kind of companies, they don't need to have that kind of environment. So your cases, most of them are used by your MSD developers and people like that, or maybe some of your test environments where that performance is not as important. But you do have, definitely Microsoft will have a huge amount of fiber channel, but that will be used by their tier 1 applications and servers. That's why. Okay.
Deepu, I'll go back to my same question earlier. You said the bandwidth is about the same, but performance is better. So what is the performance parameter that you're measuring, or what
the
is
performance parameter? When I talk about the performance is, fiber channel is light, so it will be much more faster with respect to accessing its block level storage. It's a that is the way. So the parameters, probably the latency is one of the factors you can probably use. When you talk about storage and all, there are many counters, but one of them, the most important thing will be latency. The latency means how much delay is there for a read and write and all. So when you're using light as your media, when you use that technology, it will be much more faster. So that is the factor I'm talking about. It's not about the bandwidth, how much you can provide. It is about a small percentage of disk and accessing and reading that and writing to that, how fast you can do that operation.
Okay, thanks.
Okay. Coming to iSCSI addressing, now just you know that how VMware ESX kernel or VMware kernel addresses a fiber channel, VMHBA colon, target ID colon, LAN ID colon partition, if we talked about that. Same way, when you talk about iSCSI, iSCSI is also having an addressing thing. Okay. Hey, Sujan, can you hear me? Are you there? Or somebody is logged in for Sujan to record it. Okay. All right. So I mean, we didn't start. I tried to calling you 4 or 5 times, but we just started only 2:30. But we started probably like 10 minutes back. So we're just starting the iSCSI part here. Okay. Okay. So when it comes here, iSCSI target. So this is actually addressing. So this is so we know that there is a so in this case this is the this is the target and this is the initiator. Always the ESX will be the initiator. It makes an initiator call to the target and access the storage. So this is an IQN address, or this is called as a iSCSI target address. IQN.90.08.com.netapp:store1. You see that it is actually in the reverse order. Actually, it's netapp.com is written as .com.netapp. And there is an IP address here. See, now we are talking about iSCSI, which is TCP IP. So the IP address is actually a factor. So we are using everything through IP network. So IP address is there. When it comes to the target, the initiator, look at the initiator address. This is a software initiator, which is a VMware ESX or VMware's initiator. So initiators is actually the initiator is a software initiator, which is owned by VMware. So look at the address here, iqn.9098-01.com.vmware:train. Forget about this train and store1. Those are some alias names you can call your storage also. That's a name of your storage or your initiator. But this is actually called as the IQN name. So what is a iSCSI name? That is what we will look into. Very important factor. So IQN, or it is called as iSCSI qualified name. Okay. iSCSI qualified name. There is a standard. There is a standard to use iSCSI. So you will learn how to do that. That's what we're going to do. So you're writing an iSCSI qualified name. There is a format to do that. So the naming convention is as follows. It starts with the string IQN. That is what this is. Then the year and see the date code specifying the year and month in which the organization registered their domain or their subdomain. So you know that this is a NetApp storage. That is why it is showing like this. netapp.com and the year and the date, month, sorry, the year and the month where that company registered their domain name. Optionally, and also you have to do that. See, so the date code specifying the year and month in which the organization registered the domain. That is the year and month. That is this. And then the organization's naming authority string, the organization's domain name in a reverse order. Again, this is consists of valid reverse domain and optionally a colon and then this colon and then an alias name. Okay, hold on a second then. Hello, this is Deepu. Yeah, hey Sri, class is there. I didn't see you. That's why I was trying to reach you. Right, that was the class was at 2 o'clock. So the class was at 2 o'clock. We started at 2:30, but nothing happened till around 2:55. I just started iSCSI, so if you can make it, please make it. So just everybody is there. You are the only one missing. That's the problem. No problem. So you can join. I'm just started IceKC only, and there are a few people recording the session, so maybe you can take that whatever missed. But okay, guys. So that was Sridhar. So he is joined. Guys, he was on Central Time, so be very careful, okay, because the timing confusion is always a problem. So we are missing Byron. So Ryden, you talk to him and link him with Arvind and take that recording. Okay. Again, guys, as Arvind said, don't relay him for all the recording. You guys also should help him out, because if he missed something, and when he asks, you should not wash your hands. You should have something for him. Okay. So. So the IceKC qualified name is very easy to understand. You know that it is actually it is like that. It starts with the string IQN, then the year and month where that company registers. If it is a Microsoft storage, it will be Microsoft when Microsoft registered their domain. If it is VMware, when Microsoft registered, VMware registered them, like that. So year and month and their domain name, followed by a colon, and then the name or some alias name. Alias is, a C name kind of thing. You can give any name to your storage. You can call this as Deepu also, or storage 1 or whatever. So if you look here, I can tell you clearly that netapp.com was registered their domain name in 1992. So it's an old company. It's almost 20 years into the industry now. Look at VMware. VMware registered their domain name in 1998, and I am very glad that I started working with VMware products in less than 4 years. I started with my ESX experience in 2002 actually, with ESX Server 2.0 actually, 2.5. So VMware registered their name. The VMware.com was registered in 1998 January. Whereas netapp.com was registered even 10 years, 8 years, 6 years in 1992. Okay, so that's how you come up with the IceKC name. So if it is a Microsoft server or if it is a Microsoft storage, it would have been IQN.1990 or something like that, maybe 1991 or something like that, .03.com.microsoft, something like that. That's how. So every company will have a unique name in this case, correct? Because it is their domain name. So if NetApp is providing an IceKC storage, it will be definitely with that. So this is the naming convention. This is how you come up with the IQN name. So if somebody give you this, you know that is the IQN name for a so-and-so storage or whatever it is. So we have the target name, which is the storage, and initiator, which is actually your ESX server. Okay. We will be very soon. More things. We're going to do that. These things, we will talk about it. I'm going to do more practical labs today here. So, IceKC, to understand what is IceKC is only what important. So you can see here, this is again a IceKC storage. I mean, when you talk about IceKC storage, just for Sujan and Sri, it is nothing but your same storage. Okay, it's the same storage array, but the protocol you use and the initiators and the targets you use are different. Instead of fiber channel HBAs, you are using IceKC HBAs. That's all. So, and it uses TCP/IP protocol. So you can see that in the target, you can see that there is an IP address and a port number. 3260 is actually the default port number for IceKC. Very important thing you have to remember, just like other port numbers. 3260 is the default port number for IceKC. So you can see that the target has an IP address, and you can also see that the initiator also will have an IP address. There is no IP address here shown, but you can see that from this computer, if I want to make a connection, from here to here, in this IceKC HB, I have to configure the target IP address. You see that 192.168.36.101:3260. That is nothing but the IP address of this one, so that I can access the storage, provided if I have permission. Again, This is the same storage technology. The storage administrators, they do the permissioning on who can access that. Fiber channel does not use any port because it is using fiber channel protocol, and that is a different protocol. There is no port for it. Ports are coming to TCP/IP. So there are actually two ways or two methods are there. You can access the iSCSI. One is called as a static configuration. That means you have to manually configure the target address on your iSCSI server, and you can attach to that. The other one is send target. That is basically like a broadcast. It will discover when you configure it for send targets, it will actually look into the network and see is there any storage that is offering storage. It is kind of a discovery method. We will look into that when we get into the storage. Okay. There is nothing much here to talk, guys. So we will do this lab. At that point, you will understand. So basically, there are two ways you can do the discovery: static and send targets. We will see what that is in a minute. There is one thing you need to understand. So when you have storage, yeah.
Just now you showed IP address and port number. So then what is the IQN name used for? IQN name used for?
IQN is actually, we will talk about that. I will show you. The IQN name is the actual, that is correct. That is the actual name. So, you don't need to give the name. Actually, it is mapped. The IQN name is mapped to that IP address. It is the DNS thing. So normally you can give the IP address or you can give the actual IQN name itself. It will resolve it as long as you have a DNS resolution is there. So you don't need to do that. Yeah, it is actually the thing. We will see that when we do it. It's a little difficult to understand. That's why I was just putting it that way. We'll see. I'm going to do the lab in a minute. So let us say this is a storage in Australia and this is my server in US, and I wanted to connect to that storage in this storage to my ESX server here. And when I do the data transfer between back and forth, typically when you do the transmission or communication in iSCSI, it is gone in clear text. So basically the TCP/IP, the iSCSI communication between a server and a storage is always in clear text. So that means there is a big security risk there. People can actually see what is transferring. So there is definitely a huge amount of risk is there if you are doing it over the internet. If you are transferring the data over the internet. For example, if you have a ESX server in your house and I have an iSCSI storage here, you can access my iSCSI storage over the internet, but the traffic or the data that we are transferring back and forth is actually goes in clear text. So it is very easy for hackers to tap that data. So it is highly recommended to configure if you are using WAN-based connections over the internet. If you have a dedicated VPN and all, you don't need to worry about it. But if you are using it just like that over the internet, then you may want to use some protocols that are protecting your data. So CHAP is one of the very famous authentication protocol which can protect. It actually uses CHAP means Challenge Handshake Authentication Protocol. There are different types of protocols. I'm not going to get into it, but iSCSI supports CHAP authentication. It basically it makes some handshake between. So basically, when a server communicates with this one, it is actually, let's say the storage administrator and Fanny is the ESX guy. If I am creating a storage, I will create a password here, and then I will call Fanny and say, hey Fanny, this is the password you have used. So Fanny will enter that password, and I will have this password. So when Fanny's server tries to connect, it first sends that password information, and with that, it's not a password, it is actually kind of a key. It generates a hashing algorithm. So it basically creates a hash computation value, and based on that value, if it is the correct password, then the iSCSI storage will say, okay, I understand who you are. Now we can do the transmission communication. Then that whatever the data that is being communicated between these two servers are all encrypted. So when the data comes here, this server will be able to decrypt that data into the original format with the help of that key, the hash key or the computation value it created. So that is the in general the technology behind CHAP authentication. Guys, I'm not going to talk a lot about this, but it is very good to know what is CHAP, and there are many other. I don't remember when I learned in my engineering, I think in second year or third year of my electronics and communication, I learned about all these things, but there is still, you can go and understand all these authentication protocols. It's a good thing to know. I'm not remembering all those technologies right on top of my mind, but it is a very good thing if you can go and understand these authentication protocol. It is not just used in the storage industry, it is used across the technologies in different IT technologies it is used. So try to understand CHAP and other authentication protocols. So iSCSI can be used with CHAP if you are using it through a WAN or a internet. But if you have your server here and your iSCSI storage both within your data center, then you don't need to use iSCSI or anything, because there is nobody going to hack into that data. You are inside your own network. So in that case, you don't need to use any iSCSI, any authentication protocol. So that's how it is. Okay. How often this is used in any VM environments? What are you talking about, Arvind? I don't understand.
Okay, I have two questions here. Question one is, for example, if I have ESX server in one data center and storage in a different data center, is this going to be used?
You don't have to, as long as if you have a private VLAN, and that is what I understand. If you're talking about two data centers, they are both owned by your own company, so your company will have a private, dedicated WAN link. That is actually be a service you buy from Verizon or AT&T, right? That is your own dedicated link. One T1 or T3 or OC12 or OC24 kind of a connection. Then you don't need to, because it is your own network. You are not using any public internet. If it is through internet, for example, you are buying a iSCSI storage from Amazon and trying to connect, you are using the normal internet to communicate. At that point, you may want to use iSCSI. If you are using iSCSI between your own data centers, and if that is protected, then you don't have to. But again, it's a good thing if you use it. If you don't use it, that's how it is. There is a risk associated with it. Even in your office, if you want, you can definitely use that. So this is another thing. We talked about the iSCSI hardware, software iSCSI, and hardware iSCSI. I told you what is software iSCSI. Software iSCSI is a software that is provided by VMware. We will be using software iSCSI in the class, in the lab. It is actually a software. I'm trying to explain this picture. Let me take a minute here to explain that. Hardware initiator, it is the actual initiator card, the network cards you can buy from QLogic or Emulex. Both these companies manufacture iSCSI initiators, hardware initiators. They are also called as iSCSI HBAs. So what is iSCSI HBA and what is a software initiator? This is what you need to understand. Look at this picture carefully. I'm talking about software initiator here. When you use software initiator, as I said, when we are going to use software initiator here in my lab also, in all my ESX server, I do not have a hardware HBA. I only have software HBA. Sorry, I only have software iSCSI. So when you use software iSCSI, you take advantage of your existing network card. Because iSCSI is TCP/IP oriented, it can use your existing network infrastructure. So I'm going to use my existing network cards to do my iSCSI communication. So you look at this picture, two different pictures. In my ESX server, I have my network card and my driver. So my VM kernel, I have my physical network card here. You see that? This is my physical network card. And then look at inside the VM kernel, what are the things there? There is iSCSI initiator software is there. The TCP/IP protocol is there, and the NIC driver is there. Which NIC driver? This NIC network cards driver. All these things are inside the VM kernel. You all know that, right? We know that NIC driver is actually in the VM kernel. The TCP/IP stack is inside the VM kernel. Now you are also adding the iSCSI initiator into this. Now with the help of these three things, you can do iSCSI communications through this physical network card. That is what we're going to do when we're using software initiator. What is the drawback of using software initiator? Can anybody tell me? If I use software initiator, I cannot do one particular thing. Anybody?
Boot the ESX server?
That's correct. You cannot boot an ESX server from a SAN storage if you are using software initiator. Everything else you can do. Okay, that's a rare case. If your requirement is to boot using iSCSI, then you have to use hardware initiator. Now let us look at the hardware initiator, the picture I showed. If you have a real iSCSI QLogic hardware initiator, look at this. In this ESX server, I have a hardware initiator, iSCSI HBA, example QLogic QLA 4050G. That is actually the picture I showed you. Look at inside. Inside that, if you remember correctly, look at this picture. We have that picture here. If you look at this iSCSI HBA, if you look at this iSCSI HBA, you see that there is an EPROM here. In this one, all these required softwares are inside this. This is actually a small processor itself. So when you have that, inside that hardware HBA, you have the initiator software is already there. And you can also see that there is something called TCP offload engine or TCP IP offload. What is TCP? Have you anybody heard about TCP offload? Anybody heard about TCP chimney? It's a major issue with Windows servers, TCP chimney issue. Anybody familiar with that? Anybody know what is TCP IP offload means?
It's a TCP IP software in a chip.
What is that?
TCP IP software stack in a chip.
Okay. Okay. So it's kind of, it is a kind of a TCP IP protocol stack within the network card itself. Nowadays, the latest Intel and Broadcom and all network cards you buy, even I'm talking about normal network cards, they all have the offload feature, the TCP IP offload feature. What is that means? If you have a big file server, if you have a good SQL server, SQL servers had some issues, but that is all been fixed now. When you have these kind of heavy traffic softwares running on your servers, your processor, your CPU in your computer has to do a lot of job in order to do the TCP IP communication. When it sends every packet, it has to check that packet for error proof. It has to check the stability of the, a lot of things it needs to look when it is transferring files. So if you are doing gigabits and gigabytes of transfers, your processor has to spend a lot of time. It has to spend a lot of time working on this data transfer. So you can see that the performance of your servers are going down, or you can see that the server is using. Hold on, guys, 1 minute. Yeah. No. Did you call him? Okay, guys, sorry about that. So when you have when you don't have TCP offload capable network cards, your processor has to do a lot of job in order to do the TCP IP communication. So nowadays the processors, the network cards are coming up with this TCP offload engine. What that means is, instead of the processor doing that calculations and checking and error checking and other calculations, the network card itself can do that. So what is exactly inside the network card is nothing but a small processor with TCP/IP capabilities. Not that the TCP/IP is there, it is having a processor inside that, small processors that can do. See, your iPhone has a processor. Your, you take any small, small devices, many devices. You take any phone or you take any other calculator. They all have processors, right? So each processor is meant for different things. That's it. So the network cards also come with a type of processor. It is a small processor that can do these kind of calculations, or it is meant for doing this kind of TCP calculations. So when you have a network card with a TCP offload engine, that means it has a processor which can do this kind of calculation. So what happens is your processor can be freed. It can be freed from doing this job. Rather, you can use your processing power, the real CPU power, to do other things, whereas the network card will do its own job so that it can offload. That is what it is called as TCP offload. Meaning when you have a TCP offload capable network card, this burden of processing the packets can be given or offloaded to the network card, and the network card will take care of that. You getting what I'm saying, right? So that is what TCP/IP offload means. So when you have the iSCSI HBAs, you can see that is why it is much more powerful. When you have a real iSCSI HBA, it has the iSCSI initiator and as well as the TCP offload engine. So what is inside the kernel? Inside the kernel, all you have is the iSCSI HBA driver, because the kernel needs to understand what this hardware is. So that driver has to be there inside the VM kernel, but the TCP/IP and the iSCSI software is inside that card. So that is the difference. There is a huge difference there. So definitely you can see that when you have a separate device itself to do your iSCSI communication as well as the TCP/IP communication, you can definitely see that your VM kernel is freed from doing those jobs, which means that your VM kernel can do more other things rather than focusing on these processing. So it will perform well. It is very true, but it's a costly product. You have to buy and put it. When I say costly, I think it's probably around $600, $700 a piece. So if your company is really looking into doing iSCSI, I would recommend going with hardware initiator. But VMware completely supports software initiator. If you really want, you can actually use software initiators. Okay. So that is the difference between a software initiator and a hardware initiator. Anybody has any questions on that? Is it clear? Software initiator means you are using your existing network cards on your server, and the software for those initiator iSCSI traffic is inside the kernel, the TCP/IP is inside, the NIC driver is inside, and it uses the real network card to do your iSCSI. When it comes to when you have a real hardware initiator, the iSCSI software and the offload engine is inside the card, and only the driver is inside the card. Okay, go ahead. Who is having a question?
Yeah, Deepu Arvind here. Basically, when you have the software initiator without hardware initiator, how does this the offloading takes place? How that is being done?
Offloading does not take place. The processor, the VM ESX server's processor will be doing that. There is no offloading.
Okay, then it's going to be the processor intensive, process intensive.
Yes, I mean, this is all when you talk about large number of data. Yeah, it will be. There will be definitely more load on the processor than in this case. In this case, the ESX server's processor may not have to do that much because the offload engine can do that. But again, remember, if this network card is having the offloading capability, it may do that offloading. We are not talking about that here. If this network card you are using, I told you, not only hardware HBAs, the normal network cards, what you buy today, are coming up with offload engines. So if your question is purely based on offloading, I cannot say that until you look at this network card. If this network card is having the offload capability, it can do that. But this network card does not have the initiator software. The initiator software is in the kernel. In this case, the initiator software is inside the card. That means it could perform better, and that is the reason why you need iSCSI hardware initiator if you want to boot from a storage. Okay. Sure. Offload engine, that is what I said, when you do a TCP IP communication, let's say you are doing a 10 GB file transfer between smaller files. Let's say you have 10,000 photos, which is 10 GB. You want to transfer from one computer to another computer. That copy process, when you think it is copying, but the processor has to do a lot of things, because it sends the packet. It has to see that whether the packet reached there successfully. When then that reached there, that computer will send an acknowledgement back. Then it will send the other packet. Then maybe because of some noise or something, the packet might drop. Then the computer has to resend that packet. So there is a lot of calculation, mathematical calculations happens when you do a file copy. You don't know that, but the computer has to do a lot of job in order to transfer your 10 GB files from one server to another server. At that point, you are using the processing power. Who is doing the calculation? The processor has to do, correct? That processing, which is used for that communication, if you have a offload enabled network cards, the network card can do that, because the network cards have small processors that are capable enough to do those calculations. So when you have a TCP offload engine enabled network cards, those network cards can do those calculations wherein it can free up your actual CPU. So you can use your actual CPU for other stuff, and your network card will do those calculations for you. That's it. But again, this will come into picture only when you see. Don't think that every time there are, if you want, you have to read about TCP offloads and all. There are hundreds of KB articles from Microsoft talking about TCP offloading. TCP, there are many settings to it. I'm not going to get into it, but these are some things that we deal on a daily basis in our environments on Windows servers. You can disable TCP IP offload engine. There is a lot of thing actually. Let me show you something here. If you guys are really interested, you can actually, there is a it's called as TCP chimney setting. So using TCP chimney offload. So this is thing that Microsoft has so many articles about that. If you really want, you can use these things to understand. But I don't know, if you're not much focused on it, you don't need to do that. It's actually part of the scalable networking pack. Microsoft has that thing. So there are some registry settings and things like that. So Microsoft has many KB articles. It is still not been very clear, and until I was research, I have done so much of work on this. These are the offloading DLLs and sys files that are involved, and these are some of the TCP chimney settings. So if you have, if you are really familiar with, if you go to register TCP IP HKey local machine, HKey local machine current control set, HKey user system current control set, services, TCP IP parameters. Here you can see some of the TCP IP settings. You can see that the TCPA, you can see that the chimney, enable TCP chimney. These settings, these are all now turned off. If you have if you want to offload the features, you can actually enable this. I'm just trying to show you this because this is how you really get into the Windows servers to understand how you really force your Windows Server 2003. You don't need to do that in 2008 R2 and all. If you have 2003 and previous versions, and if you want your Windows servers to really do offloading, you have to do these kind of registry punches in order to make this thing. You can see that this is the parameters: HKey local system current control set services, TCP IP parameters. Here you have to go and enable these features, but that is all Windows servers. I don't think I wanted to confuse you guys, but TCP chimney is not just a VMware feature. It is actually a general thing which people can use to push the job of copying files or file related issues, things, processing power to what I'm saying. It will allow you to offload the processing, or it will help you to free up your processor to do other things. whereas the network card will do those jobs for you. That is the whole thing. That is what an offload engine is. Okay. There is nothing much rocket science there. Now, if you have a TCP offload engine enabled network cards, it can actually take the job and do better file transfers than your processors can do. And also the processors can focus on other things rather than focusing on this. Again, one more thing I want to tell you, the TCP offloading will come into effect, or it will do that only when there is a certain amount of data. If you are doing a 1 GB file transfer or 2 GB file transfer, or you are doing some small file copies, offload engine will never take into account it. The processor will do that. If you are doing so much of file transfer in so much seconds, I think it's I don't know the number, but I think it's like 1 GB per second or per minute or something. If you do that, that is when offloading will really take place. So on small file access and for file copying, TCP offloading will never get into action. It will only trigger when there is a certain amount of data is there. Okay, so setup and networking as IceKC. How do you set up IceKC software initiator in ESX server and all? That is what we're going to do. So any questions so far? So we're going to do some real stuff here, guys. Any questions on that concept of IceKC? I don't think there is any problem. It is clear, right? So let me talk about certain things now. So how do you access IceKC in your thing? So let me explain something about my environment here. Okay, I have a IceKC server here. I mean, I'm not going to get into that configuration of that. It is actually a device that is inside my lab, which is basically divided into two sections. It can be actually used. I will talk about how to configure this and help you guys. It is actually a freeware. You can also use that in your house and all to learn these things, because I didn't spend too much money to buy a real costly IceKC thing. Don't think that I have a big storage array and all. No, I don't have, but it is a pretty good software that can let you create IceKC and NFS, things like that. But it do require real storage. I have so much storage, so I have some. That is why I said one of my server is dedicated for this storage. I have almost a terabyte of storage there presented to these. Not a terabyte. I think around 700 GB or something is given to this. So I have a IceKC here, as well as NFS or I would say NAS in this device. It is divided into two things. So there are disks. There are actually IceKC configured disks inside my things, or you can say that IceKC LUNs are available. And then there is some storage available inside. A couple of volumes are available inside my NAS also. So this is a device. I have it here. This is my IceKC store. So this device has an IP address. And that IP address is actually 10.10.10.201. What am I typing? Okay. .10.10.10.201. This is important for you all to understand that IP address. This is the IP address of my IceKC device. I mean, both these services use the same network card. So I have a network card here, which is basically our target. This is the target thing. It will have an IceKC initiator address and all. We will look in that. So this is my thing. And then I have my ESX servers, 1 ESX server, 2, 3, 4, whatever ESX servers. You can all connect to this thing and access the storage. So this is an external storage, but you can access these storages into these ESX servers. Okay, you understand what I'm trying to tell you here. So that is what we're going to do. But in order to access these storages inside your VMware ESX server or inside your VM kernel, you have to do certain things. You have to configure this. We're going to use software initiator and things like that. That is what we're going to do. Okay. So first thing is, you can see that both service console, you don't need to do this, is a whole document, that's why. But you need the VM kernel to do iSCSI thing. It is actually iSCSI communications are happen through VM kernel. So a couple of things, I think I don't need to do all these things. I'm going straight into the iSCSI thing. Here when it comes here, you need to understand a few things I wanted to show you, few things I wanted to explain. Here. See, I only have one iSCSI storage. So everybody should look into this carefully, because once I configure it and add it, you can see that it is all going to come on all servers. So be very careful of what I'm going to do. So what we need to do is, this is my ESX server, this is the storage, and you can see that there is no other storage. This is our local storage. Okay, this is our local storage. If you go to the storage adapter section, you can see that there is no other thing. There is only the smart array, and then these are the local controller. You can see that that's your CD-ROM drive and all. Nothing is there. If you go to the storage and click on add storage, click on disk LUN, because we use, when you're talking about, you can see that create data store on fiber channel or iSCSI or local SCSI. You have to use this option. If you're using NFS, then you have to use that. So we will talk about NFS later. Let us look at iSCSI. So that's why we have to click on disk LUN. We click next. If there is any storage available, it will show up here. Right now, there is no storage listed here. There is nothing to add, so you cannot create it. So we're going to do is, we're going to configure software initiator first. So in my ESX server, this particular ESX server, we can see that it has a network card. Let me take this. I'm not using this server. Let me take one of your server which you built. Okay, I'll take this server. You can see that it has two network cards. This is the networking card and stuff like that. So I told you, iSCSI is going to, we are going to use software iSCSI. Okay, imagine that picture. We are going to use software iSCSI. So when we are going to use software iSCSI, it is going to use your existing network cards to do the iSCSI communication. I also said iSCSI requires a VM kernel port group. So we need to create that. So what we need to do is that these are some things you need to do. First thing is, iSCSI requires a VM kernel port group. Okay, so what I'm going to do here is, I'm going to go to the properties of this network card. First of all, let me remove this thing because I don't think that is needed. So I just made that clear. There is only one thing here. How many network cards are here on this server? Only two. Okay, that's fine. They both are active. Unfortunately, I can see that one is showing 100 full. That's not really good. It should have been 100 full. But if you look at any other server, you can see that it should be probably both are 1000. Okay, here it is actually good. This server, whoever worked on this, that's a good job. Whoever did, there are many port groups and stuff like that. That's good. Let me look at this one, 97. Okay, that's also having 200 full connections. Good. I'll use this server to do this because I have this full connections and all. So as I said, the first thing we need to do is we have to create a VM kernel port group for your iSCSI communication. That is the first thing. It needs a VM kernel port group. There is one VM kernel port group, but that's not enough. You need to create another one. So what I'm going to do here is I'm going to create a VM kernel. I can create it inside here or inside this switch. I can use any one of the switch, but I'm going to do here is I'm going to create a VM kernel port group inside this first switch. Add VM kernel port group. We haven't done this before. I'm going to create a VM kernel port group. When you use VM kernel port group, you can call it as, I'm going to call it as ISKC. And you have to use this. You don't need to do anything here. You can just leave all these things blank. Click next. When it comes here, you have to give an IP address to your ISKC thing. So you know that when you use a VM kernel port group, it needs an IP address. So I have to give an IP address. So I'm going to use 70 and see if that is possible. Okay. 70, 71, 72. Okay. Somebody is using. So let me see 60 I can use. 60, 61. Oh, that's also wrong. Who is using all these IP addresses? Anyway, we can use 70 for now. It is not pinging. So I'm going to use IP address 70 for this 10.10.10.70. 255, 255, 255.0. The subnet by default gateway is same for my network. Finish. So now if you look here, you can see that I created a VM kernel port group with an IP address 10.10.10.70. This is not, this is going to be used for management traffic? Anybody? Do you think this will be used for the management of the ESX server? No. It is not, because it is not configured for management traffic. If I want to use this for management traffic, what should I do? Go to the properties, click on that, and then enable it for management. Then only I can use it for thing. If I want, I can do that. So I created that thing first. So first I created this VM kernel port. So that is the first thing you need to do if you want to do ISKC, because ISKC communication requires a VM kernel port group to be defined. First step in ISKC. Second thing is you go to your storage adapters. In the storage adapters, you can see that there is a smart array controller. This is the smart array which is having our current local hard drive connected. You can see that the size is around 101 GB. And then there is the normal other, these are the two HBAs. I have two HBAs on that server, but if you click on both the HBAs, these are actual fiber channel HBAs. I told you some of my servers have HBAs. See that I don't have any HBA, any data here, nothing. So we don't need to worry about it, but since it is there, it is showing there that has two HBAs. These are also storage adapters, correct? See, you can see that this is the real HBA, and that's the WWN and all those things. Don't worry about it, but we don't have any ISKC. So I'm going to click on this add button. That will give you an option to do add software ISKC adapter. So it is what we are going to do is I'm going to create an ISKC software adapter. I told you that comes with VMware. So you click on that, it will enable a software, new ISKC adapter will be added to the storage adapters list. So click on that, you can see that it is going to come, a new ISKC adapter will come up there. It is doing it here, okay? Here you go. It created an ISKC software adapter here, and look at the IQN here. By this, can you understand what this is? Can you understand that I can look at that IQN on top of it says W? That is the unique name of that thing. I know, Santosh, you were asking earlier IP address, but IP address, that is the default address. It is like the, now I can explain it better. It is like your IP address and your MAC address. So IQN is something very similar to your MAC address or WWN. So that is the unique address for your ISKC adapter. So it created, and you can know that it is a VMware's ISKC adapter. So it has the IQN is VMware's IQN, correct? IQN.1998-01.com.vmware, and the alias name is that host 97. That is a unique number it created based on this host. So it took the host name and then it added something. You can actually change those values if you really want. So this is the ISKC adapter. You can see that VMHBA33. It is the ISKC software adapter. This is the IQN, but there is no disks or anything here. You click on the Properties tab here. You have to do certain things here. This is where we're going to do that. So when you do that, when you do this, you would have seen that if you go to your security profile, you can now see ISKC protocol is enabled. Okay, it is not enabled. We have to do that now. 1 minute. Okay. Okay. You go to the properties, and you can see that the software ISKC client, we have to enable that. You don't need to enable it now. By starting that, it will enable automatically. I'll show you that you can do that, or you can actually enable, because you're going to do ISKC communication. So port 3260 needs to be opened. So you can do it this way. You can enable that. So now you can see that the ISKC port, that is the second step you need to do. So now you see, you can see that the ISKC client is enabled, the port is open on that server. So third thing basically. First thing is create the VM kernel port group. Second thing is enable the software ISKC adapter, and then go and enable that port. And now you go to the properties. So this is the properties of your ISKC adapter. If you go to the configure button here is what you have to do. Actually, you don't need to go and enable the port here. If you come here and you say this enable, and you can see that this is the ISKC name. You can change this name if you want here. Not the IQN, you can change this alias name if you really want, but it is not recommended. So I strongly recommend not to change this. If you change this, it may not work. So I'm not sure, I never tried that, but it may work, but it is recommended not to change this default generated name. And you can say, okay, here. So you can see that it is enabled. That's the first thing you need to do. Second thing is go to the network adapters tab. You need to, yes. It automatically, that is called the alias, it automatically generates that. You don't need to do anything. When you enable it, it will understand the name of the host and it will generate a random value here. Yeah. So you click on the network configuration tab, click on the add button, and you can pick, you can see that, that it will show you both your VM kernel port groups. In your server, in this particular server, how many VM kernel port groups are there? In this server, how many VM kernel port groups are there? There are 2 port groups are there. One is, let us go and look at it if you have a doubt. Go to your networking. See, this is the first one, management network, which is called as VMK0. And the second one, which is called as VMK1. Is there any other VM kernel port groups here? No. So there are 2 VM kernel port groups. As I said, ISKC can use, ISKC needed a VM kernel port group. No matter what, it needed a VM kernel port group for its communication. You could have used this one not itself, but it is recommended to create a separate port group for ISKC communication, and that's why I created another port group. So what I'm planning to go is I'm going to use this VMK1 for my ISKC communication, not VMK0 for my ISKC communication. Okay? So I'm going to go to the storage adapters, click on the properties, and go to the network configuration tab, add the ISKC VM kernel port group. See that I'm going to enable that for my thing. So it is going to be VM kernel VMK1. It is on vSwitch 1 ISKC, and it is IP address is 10.10.70, 255. This is the version. This is all the thing. These are the details. 100,000 MB, and it's also recommended to do ISKC using at least a 1 gig connection, minimum 1 gig. So you can enable that, and you can see that it is compliant and it is working. So you can actually use this information. when you are using, so that is the second or third step you need to do. It's very simple. I'm going to show you. Once I do this, you guys will understand the whole thing. We will do the same thing on another server. Next, you come to the dynamic discovery and static discovery. I told you there are two types of discovery methods are there to discover iSCSI storage. When you deal with iSCSI software initiators, it will only work with dynamic discovery. Static discovery will not work if you are using software initiator. So you click on the dynamic discovery and click the add button. And here you have to give the IP address of your iSCSI server. That is the target IP address. If you remember this picture correctly, few minutes back, you see that I was connecting to that storage using the IP address and the port number. That is what I'm going to do now. Look at this picture. I'm going to connect to this storage. So I'm on this ESX server and I have to give the iSCSI server's IP address. What is our iSCSI server's IP address or the iSCSI storage array's IP address? The target IP address is 10.10.10.201. Isn't it? I told you. You don't know what it is, but that is my storage. You have to, you have to believe me. That's the storage. So I'm giving the IP address of my storage. That is this picture I'm talking about. This is the iSCSI address of this storage from one of my ESX server. I'm doing that. And this is the port number. If you want to enable CHAP authentication, this is where you need to do that. In my storage, in this one, I don't have any CHAP enabled. There is no password protection because it is within my thing. But if you want to use CHAP authentication, you can use that. You can actually enable the CHAP information. You can put that. You can do that. Sorry here. Do not use CHAP. You can use this different use CHAP. You can use the CHAP authentication. Then you can give the name. You can give it a name. My storage. And then you enter the password, whatever he is giving, and then you can do that. So this is something you as if Fanny was the VMware administrator, Fanny will be entering the password which I gave him. But then only it can communicate. But in my case here, we are not using CHAP authentication, so we don't need to worry about that. But this is where you configure the CHAP authentication. If anybody wants to use CHAP, this is what you need to use. Use CHAP and do that. Okay? I'm just showing that. So here is the thing, we're not going to use any CHAP. This is the storage, and I'm going to say OK. So you do that, and you can see that it is now connected to that storage, iSCSI server location. You click close. Once you close it, it is not going to do anything. It is going to scan. So what is going to happen now is you can see in the bottom, this server is now going to scan this IP address, which one, 10.10.10.201, and going to look, is there any storage? It is a discovery channel. It is going to see, is there any storage available in that port number where I can use? So I have my storage. This is one thing your question may be, how do the server is able to see? I have a iSCSI storage which is configured, it has its own software, which is configured in such a way that what I have said is, allow it to connect from any servers coming from the IP address 10.10.10.x. So any server with an IP address 10.10.10.x, x meaning from 1 to 254, try to connect, give it a storage. That is what my configuration is. That is why I'm able to do it. So what I'm doing here is I'm going to scan it, and my server is now rescan HBA. You can see that it is scanning now. If it finds the storage, you will see them here. See, here you go. It found 2 storages. See, these are not very big storage. I don't have that much storage, I told you, but I'm using it for NFS also. What is this now? You can see that there are 2 iSCSI storages. One is 24 GB capacity and the another one is 25 GB in capacity. This is a shared storage from one of my servers. Is this clear for you? Anybody has any questions on this? At this point, let me ask you. So you understand what I did here? I configured the iSCSI adapter and I scanned it. Now, see, now in this server, if you look at my smart array controller 6i, this is my local array controller. I can see my local drive, 101 GB. This is my HBAs. There is nothing there, so we don't have to worry about that. This is my local CD-ROM drive, and now this is the iSCSI software adapter. You click on that, and it is saying that, hey, you know, I can see 2 storages. Are these storages formatted? No, we don't know. So what we need to do is, now you have this, now you go to the storage, and it is already has come there. Okay, this is because it's already been done by my students. So let me just delete this. This is not the way to do that. I mean, this is already configured in some other server. That's why. Okay, hold on a second. Don't worry about that. This is why I said it is something you need to do here. Okay, it is coming up again. Because it automatically detected that storage and it sees that it was formatted. That's why. Okay, so that's why I'm saying it's a shared storage. So it is being used by some of my other servers. So what I'm doing here is I'm deleting those storage now for a minute. You know that when you delete it, it is a complete delete. It is going to remove that whole thing. So let us see what happens. Okay. Okay, first thing is, this is my local data store. We talked about this, you know, when you have local storage, you always name it with the local storage _01. Now you have to go to the add storage. Why? Because you want to add these 2 storages. These are the 2 storages that can be seen by your server. So go to the store button, click on the add storage and click on the disk LAN. You click next, you will be able to see 2 storages there. Pick your first storage, click next. There are 2 types of VMFS file system are there. I told you VMFS 3 and VMFS 5. VMFS 5 comes with ESX server 5 onwards. If you have a ESX servers that are 4 or 4.1 in your environment, it is strongly recommended to use VMFS 3 because ESX servers 4.1 and below cannot read or understand VMFS 5. VMFS 5 is the new file system. This is actually using a GPT protocol. It can be more than 2 terabyte in support. There is a lot more features are available with 5. It is using different block sizes and things like that. Whereas VMFS 3 is the old protocol. So if you have ESX servers that are 4.1 and prior, you should create your storage with VMFS 3. Here in our environment, all are 5, so I'm going to use VMFS 5. This is the name. You click next. Now you give it a name. So what I'm doing is I'm going to format that data store with the VMFS file system. Okay. You can see that the partition format is GPT because it's called as GUID partition table. That's another partition system which can allow you to create more than 2 terabyte size. The other one is the normal, what is that called? It is actually called as the forgot, normal partition. I'll get you that name anyway. That's a different partitioning system. That's what normally everybody uses. But now with VMware, a new version onwards, it supports GPT. So click next, give it a name. So I'm going to call it as iSCSI _ storage _01. This is my first iSCSI storage, and I'm going to give it that name. Click next. It's asking, do you want to use the whole 24 GB or not? I'm saying, okay, use the full space. And this is what it is. You can see that the data store name is this. The file system is VMFS 5. The block size is going to be 1 MB. Maximum file size is 2 terabyte. That I will be talking in a minute. when we get into the VMFS. Next chapter we'll talk about that. Currently I'm just showing how to create a iSCSI storage. So click this and finish. Now you can see that the new storage will come up here. It is creating that file system here. You can see that. Here you go. So your first storage has been created. It is an iSCSI storage, and it has all the thing. It may have some file systems. I'm going to browse it and see is there anything there. There is nothing there. It is clean and neat. I'm going to create a new virtual machine here. Please, it's slow. Okay, something is going on. Okay, my vSphere client is hanging. That's okay. I have so many things open here, that's why. Come on. Yes, in real time you will ask your storage administrators to provide you the storage, but adding that storage using Fiber Channel or whether using iSCSI, it is your job. So what we are doing, all these things what we are doing, we have to do as an administrator. They will be creating the storage just like I said, okay, I have a storage, there is storage. It is mission for your ESX server. And this is what it is. So we have that storage here. Let me back here and show you. We have that one iSCSI storage we created here. I'll create a new VM. Custom. Let's call it as iSCSI underscore test. I'm selecting, now I can select two storage. I have my local storage, which I have a 53 GB free space, and I have the new iSCSI storage, which has 23 GB. See guys, my whole purpose here is not to build an enterprise environment here. My purpose here is to teach you guys. So I don't have too much of space. I wanted to show multiple storages and NFS and also. That's why I purposefully created my iSCSI storages as very small. So we have some space limitations, so please use that sensibly. When I say sensibly means try to create your VMs with small size and also always use that thin provisioning option. So I'm creating this 23 GB size. If I create a 20 GB VMDK, then that is full, right? So these are the different versions of VMware hardware version. I told you there are different versions of VMs you can create. Version 4, version 7, and version 8. The latest version is actually it's version 9. Why is it not showing here? It's supposed to show version 9. Sorry, version 8. This is the new version. This is the version, no, version 8 and version 9 was that. Okay. So this is the one that comes with ESXi 5. This is with 4.1, and this is with older versions. So you can use any of the hardware versions, but if you are using ESX 4 or 3, you should use this version. So I'm going to use the latest version. You know, it is just some features are available more on the latest hardware. That's it. So I'm creating a hardware version 8 VM. Just selecting something. Let me select a Linux Ubuntu VM here. Ubuntu 32-bit or 64-bit. I'm selecting 32-bit VM here. One processor, 1 GB RAM, one network card. You know, you can, you know, what are the networks? You know, we have 2 network cards, so I'm going to use my first network card. Click next. Logical drive. Create a new hard drive. I'm going to use, I don't think we need 16 GB, that's fine. I think to install Ubuntu, you need only like something. But I'm going to use the thin provisioning, so it will only use what is exactly used. It will not allocate or pre-allocate that 10 GB. I will talk about that when we get into the storage properties. I'm storing it with the virtual machine. I'm not storing it on a different storage. I'm storing that disk along with my VM's working directory. You all know about that. Click next, next, and finish. So I created my iSCSI target VM. Now if you go to the iSCSI storage, you can see that VM's files are all sitting here. I can power on that VM. You know that when I power on, you're going to see some more files, correct? You can power on that VM. So now you know that VM is actually, see, it has all the files, and that is actually sitting on a shared storage. Is it on a local storage or on a shared storage? iSCSI test is now sitting on a shared storage, isn't it? Any questions on this, guys? So this is how you add and remove, add and store VMs, you know, iSCSI. Now if you want to create the next storage, sure, you can do that. You can go to add storage, disk LAN, click next, select the second pending storage, click next, do the same thing, VMFS3 or VM. You can do VMFS3 also. And you can add this storage, click next, give it a name, iSCSI underscore storage. You know, you can do like that, click next, and do all these things and finish. I'm not going to create that. I'm going to leave that for something to show you because I only have 2 storage here. Is this clear for everybody? So this is the step. These are the steps we need to do in order to create an iSCSI storage to an ESX server, or in order to present an iSCSI storage to your server. There's a lot of things we discussed. Understand, it's not that simple as you're watching a movie, you know, it's easy, but there is a lot of things you need to do. Give me a second, guys. So let's, guys, do one thing. Let us take a quick 5 minutes break. What I'm going to do here is I'm not going to take a break, but, you know, let us take a 10 minutes of break or something. What I'm going to do here is this is what I want to do. Oh, okay, hold on. 1 minute, guys. It's 97. I'm going to go to 96 now. Root and password. So we go into 96 and password. Okay, here is what we need to do. I'm going to give the control to Sri. Okay, Sri, you will have the control now. What I want to do is, don't do it now. This is what I want to do now. This server, go to the configuration tab. First, make sure. I want you to attach this server to storage. If you go to the storage of this server and you click add storage and disk LAN, you don't see any storage. Why are you not seeing any storage? Can anybody tell me? Because this is not presented to iSCSI. See, remember one thing here. This is how the environment is now. Okay, you have to understand this. This is my iSCSI server. This iSCSI server is having two iSCSI LANs are configured. One is, let us say, a green LAN, and the other one is a pink LAN. There are two LANs inside this iSCSI storage. This is my iSCSI storage. 10.10.10.201. That is my iSCSI storage. And now we have 4 ESX servers which are built by you guys. 1, 2, 3, and 4. The IP addresses of these servers are x.97, x.96. I'm not putting the 10.10. That's all. x.91, correct? And what was the other IP address? Anybody remember? x.95, correct? So right now we are on 96. So we already configured this server, the blue one, which is 97. We already configured it to this storage. Now the blue one can see that green LAN. It can see this also, but we have not configured this as a data storage. So basically, this server can see that green LAN. It can see the ping also, but I have not converted that into a VMFS. The server can still see it. I want to show you certain other things like the RDM and all. That's why I purposefully didn't store it. Let us wait for that. So this is the first storage. Now what I want Sri and you guys to do now is, I want you to add this server 96 in such a way that it can see this storage. This storage only, not this one. So in order to do that, can you guys tell me what all you need to do on this? Now I am on that server. First, let us rename this. See, this is the thing I was telling you. When you rebuild a server, we have to configure local underscore storage underscore 96_01. It is needed because when we get on the clustering and all, it will be very important. So this is the local storage. Now I want you to add that LAN to the storage, but I don't see that here. So what do we need to do? So you know that. Can anybody tell me what are the steps we need to do? What are the steps we need to do in order to do that? Sri, do you have control? Can you move your mouse? Okay, you have control. Okay, good. So guys, Sri is going to control it, but you guys should drive him. Please tell him, please talk and do this, guys, okay? Discuss this. I will be back in like 5-10 minutes. I will be watching, but I will be back in 5 minutes. So let us try to do it and then you can take a break. But look into this and let us see what is happening. Before doing, let us stop or let us iron out or write chat in the chat window. You can type or what all you need, or maybe Sri, you can take a notepad and type what are the things you need in order to do that. What all you need, what all are to be done. You know, make sure all those things. Meantime, before doing that, let me just do a small thing here. Okay, here you can see that these two network, one is 100 and the other one is not 100. So what I'm going to do here is, guys, I'm going to come here to the adapters and I'm going to remove this VMNIC2 from here. I'm going to add this VMNIC1 into that. So it got detached from here. Then I'm going to come here to this, add, and then I'm going to do VMNIC2 to that. I don't know what you understand here, but what I did is I just flipped the NIC cards. All I did was just flip the NIC cards. I put the VMNIC2 to this, and I put a VMNIC0 and 1 to this first switch. So here is this is a different type of a server. It has different network configuration, but whatever it is. So I don't know what you need to do. We need the storage, and that is it. So you want to talk? So I can be here for 5 minutes.
Hey guys, this is Shrey. Hey guys. What is the first thing we need?
VM kernel port.
And the second one is anybody?
Storage adapter initially.
Storage.
We go to the storage adapter.
Yes.
Okay, you guys do. I will be back in 5 minutes. Okay, I will be here only, but I will be back soon. Okay.
After adding the storage adapter, what is our next step?
Add a storage. To your ESX. Add storage to ESX. Then create a VM on the new storage. There you go.
All right, let's do it. Let's go to the networking, and we already have a VM kernel port. Should we use this one, or shall we create a new one?
You have to go for the new one.
Click add network, and we're going to choose VM kernel because iSCSI requires VM kernel, as Deepa explained this. Next. So
Why can't we use the one that's already there?
say that again?
Why can't we use the VM kernel port that's already there?
That's a good question.
Because yeah, okay, I can explain that. Because for every of these, like when you go to the production environment, for the it is a good practice to keep.
Listening this. Now that you open the path, this is what you need to understand. Now you open the path by configuring iSCSI software adapter, configuring the VM kernel port, and pointing it to this iSCSI storage array. Now that this server can also see these two LUNs, correct? Now it is since this LUN is already formatted with VMFS. ESX has a feature, if it sees there is a VMFS and if there is no restrictions, it will show that storage. So you, without doing anything, automatically that storage came up here. That is why you are seeing here. You didn't have to do anything because every time you format means the data will go, right? Let us say now we have our VM here. Now you see here, even though you are on 96, you open this thing here, you can see the iSCSI attached VM here.
Right.
Because that is a shared storage. Now can you say that it is a shared storage? Absolutely. Because your VM, that iSCSI test, is currently sitting inside this storage, isn't it? It is inside this storage. But right now that VM is configured to work with this ESX server. But this ESX server can also see that storage, isn't it? It can see that storage, but this VM is currently running here. That is the advantage of a shared storage. Now, let me show you something here, which is very interesting. I can actually come here. I'm going to power off this VM for a minute on 97. And I'm going to not delete this VM. I'm going to remove it from the inventory. You see this? I'm removing it from the inventory. I just removed that server. Did I remove that VM or I only removed it from the inventory? You can see in the bottom I did unregistered. Now I am going to the 96 server which you just built. I can go to the iSCSI storage. I can browse to that thing, and as I was showing earlier, I can add this to the inventory of this server now. You see now what happens? I don't have to do anything. Now that server is become part of this server. You see that? See here? Now I can power it on here. Now, exactly speaking, you can see that okay, there is a problem here. That is something we need to. It's a copy option. I have to just enable that. Yeah. So you can see that now that server has come up here in this server. Why all these are happening? Because it is a shared storage. Now that VM is actually running on this server, isn't it? You're getting what I'm trying to tell you here. Where is, in which VM, which ESX server the VM is running now? It is running on 96. But the storage is still same. All I did was I moved that VM from this storage to another storage. Sorry, this server to another server. But that is not vMotion or anything. I powered it off and registered and re-registered. But I'm just trying to show you here is that both the servers can see the same storage. So now I can say that this green line is a shared storage between these two servers. You can make this shared between these also. That means all these servers can see that storage. So the next step we need to do, or I want you guys to do, is you have to configure the same iSCSI things on these two servers and add them also like this. Any questions on that? Is that clear? Anybody else has any questions on that, what I said? Did you understand what we are doing here? Guys, if you have question, please ask. Okay, if you don't ask question, you will be completely confused. I want to make sure that you're all understanding it. Right in, Jean, Sujan, you understand what I'm trying to do here, right? Huh?
One question. For example, like now you have removed from inventory of one ESX, and you added to inventory on the another ESX server. Is it similar to the vMotion that you move ESX from one to another, VM from one to another?
No, I told you vMotion is the process of moving a running virtual machine from one ESX server to another ESX server. So that is not vMotion. I didn't talk about vMotion here. vMotion requires many other settings. You cannot simply do vMotion. Okay. And you cannot do vMotion without vSender. vSender has to be there to do vMotion. Without vSender, you cannot do vMotion. So that is first thing. So we don't have to look at vMotion now. We will learn vMotion, but these are all some of the prerequisites for doing vMotion, shared storage, things like that. So what we are doing is not vMotion. What we did was powered off a VM. So if you really want it, if I try to, see, there is no option called migrate or anything. I don't see any option to do migrate or vMotion, anything here. If I want to move this VM. If I go here and storage and try to add this server back to this, it may not allow me to do that now. Because it says, hey, you cannot do that because that guy is already running. You see this now? I'm trying to do this on 97, and if I try to come here, you see that add inventory option is there or not? It is grayed out. Why is it grayed out? Because that VM is now currently running on another host. You get this option only if that VM is powered off. Okay? So that is what is iSCSI. I'm not going to go into the detail. I wanted to cover some more stuff. Guys, anybody wants to take a break? If we want, we can take a break, and I wanted to get on to the next talk. And I can also take this call. So do one thing. Let's take a quick break of 10 minutes, okay? 10 minutes break. Let us do this 10 minutes break, and then I'll come back. Meantime, let me attend this call, guys. So 10 minutes break, and I will be back by 5 o'clock, okay? To get on to some other stuff now here. You know that we have one more iSCSI storage yet to be added. The reason why I have not added that is I talked about the RDM, right? Raw device mapping, meaning without configuring that storage as a VMFS file system, if you want to create Microsoft clusters or things like that, you can present that disk, meaning this second disk, this one, you can actually give it to a VM directly. I'll show you how to do that. That is called as row device mapping. The internals of how RDM will work, I will explain later, but I just wanted to show you how you can do that to a VM. So here, look at this VM. This is the Raiden has built this VM Windows 2008 R2. Let me take a look at that VM. Okay, that's good. This VM has the VM is it's a little difficult to work on this. You can see the mouse is a problem. Let me see. He has installed the VMware tools. See, the first thing is he has not installed the VMware tools. Let me show you that. I know you all know I explained this. So I'm going to install the VMware tools here to the guest and install upgrade VMware tools. This will automatically install the VMware tools on this box. VMware tools is nothing but a set of drivers that will enhance the performance of your mouse. You can see that the mouse movement and all is not that great inside a VM. So I attached that thing. It will automatically pop up now. So you can see that the VMware tools is come up. You click on that. It is basically an MSI that is got mounted to the CD-ROM drive from the ESX server. And it is installing the VMware tools. VMware tools, once you install it, you can see that your mouse performance is much more better. Windows 2008 R2 or Windows 2008 has a different driver. I will explain that also later. But at this point, at least we should have the tools installed. So that is what I'm doing. And once you install the tools, it requires a reboot. So let us watch for that. So any VM you install, it should be advisable to install VMware tools. Gene, why do you have to restart your PC every time? Now I'm asking Gene, he's saying, Deepu, I have to restart my PC. So I'm not understanding why he needs to restart. As long as he can type the message, so what is the reason? It's not hanging or anything. So I don't know what the problem is. I'm curious. So this is the VMware tools installation. You don't need to.
Deepu, if I have a, let's say, Linux VM.
Yeah.
Are you doing this on an ESX server or on a VM?
No, I'm doing inside the guest OS. So the VMware tools is installed inside the guest OS. So whether it is a Linux or whether it is a Windows, you have to install it. Depending on the operating system, it will automatically mount the appropriate VMware driver. So you don't need to worry about which one. It will automatically pop up. So you have to install it. For Linux, you have to follow the procedures of Linux installation.
Okay.
You can see that it is installing all the drivers, VMX driver, these are actually some latest Windows drivers, mouse drivers. You can see that it is installing some drivers. These are some enhanced drivers which will give you much more better performance. Always important to keep your VMware tools updated. If you upgrade your ESX server, it is strongly recommended to upgrade your VMware tools also. Also remember, in 2008, once you finish the installation, it will ask you whether you want to reboot or not. You can say no and you can survive. You can see that once you install the VMware tools in the bottom, you can see that the VMware tools will come up. It is recommended to reboot. So I'm going to reboot this VM, but in 2003 and 2000, even if you say it will reboot the server in less than a minute. So be very careful when you're doing that. If it's a production server, do it with care. Don't do it during business hours because it will restart your server. But in 2008 and R2 onwards, if you say no, it will not reboot. Otherwise, there is no way to suppress that on a Windows 2003 or 2000 or NT 95, those old operating systems. Right, and what's the password for this? Welcome one. Not working. Two L. Okay. I think that was it. It was 2L. Okay. So nothing to do here. What I'm going to do here is I just want to do certain things here. So this is the Windows 2008. Those who are familiar with Windows 2008, you know what it is. So I'm going to the storage section here of this VM. So what we are going to do here is, if you go to the disk management, you can see that this VM currently has one drive, the C drive. They basically look at one disk. It is only having one disk, and that disk is divided into two. You know, this is a system reserved partition. It's an 100 MB partition. Normally, Windows 2008 do that. There is a way to get rid of that if you want, but you don't need to worry about it. But this is your one drive. So what we need is, what I need is, if I want to create another drive, meaning disk one, what should I do? If I want to create another drive to this VM, what should I do? Anybody? I want a D drive for this server. LUN setup. What do you mean by LUN setup? I don't know. What should I do, Arvind? That is what I wanted to know. Anybody else?
Generally, it will show all the physical drives you have. So you have to somehow tell it to look up for the raw device.
No, you have to, basically there is no raw, we are not, don't confuse the raw device. So right now there is only one drive, so you can go to the VM, its settings, add a new hard drive. It will be another VMDK file, that's all. You can go to hard disk, next, create a new virtual disk. Let it be 40 GB thin provisioned, next, finish, and do. You're done. Basically you added the second drive. Now it's not showing here because you have to scan. That's typically it is. So you can also always do a rescan disk. So when you do that, you can see that the new drive will come up here. Not here. It will come up here as a unallocated space. You can see that the disk one has come online. You can come here, make it online. These are all Windows stuff, and you can actually format this, initialize the disk. Now come to a simple volume, you can format it with whatever it is. It is going to be E drive or whatever it is finished. So now that server is having two drives. It is formatting. I selected the normal formatting, so it's going to take some time now. I should have selected quick formatting. But anyway, don't worry about it. It is going to format. Let it finish the formatting. But meantime, let us go and look at the VM's drives now. So if you go to the, if you go to the VM's properties here, okay, it is finished the formatting. So now you have two drives. If you are doubt, you can actually go to the Explorer, my computer. You can see a C drive and a E drive. There are two drives now. But the difference that these both drives are actually VM decays. So how do you know? So if you go to the 2K8 VM, go to the summary tab and go to the storage where that VM is stored. Browse, you can see a Raiden 2K8 VM. And if you look at these VMs files, now you will be able to see two VMDK files. The first one is this and the second one is this. There are two VMDK files. The first one is a 40 GB hard drive and the second one, this is the first one, 30 GB hard drive, and the second one is a 40 GB hard drive. These are the two ones. These are VMDK files. But that is a VMDK file. But if you have that kind of thing, you are accessing it through the VM kernel. So if you are talking about it and if you're really keeping your architectural diagram in place, this is your ESX server and this is your VM. You have a LUN here attached to this server, and you have this is your VM, and if this VM is having two drives, the C drive and the E drive, these two drives are nothing but two VMDK files inside this VM folder. So in this case, this VM is accessing this LUN. Even though you are inside the VM, you are seeing a C drive and D drive. Actually speaking, it is taking advantage of the VMware kernel. It is going through the storage stack and it is accessing these two drives through using the virtualization technology to seeing these two VMDK files. But that is not the thing I'm going to do here. What I'm going to do here is I have another LUN on this server which is not formatted with VMFS. It is sitting here as a row LUN, and what my goal here is to attach this LUN as a whole to this VM directly. When you say directly, it means it is coming through the thing. Basically, I'm going to present this LUN to the VM directly, not to the server. It is seen by the server, but it is not formatted. So I'm going to use this LUN as a device, as a third disk directly, the whole disk I'm going to add to the server. That is what is called as RDM, row device mapping. How row device mapping actually works is when you create RDM, it actually creates a small file called as a mapping file inside this working station. So basically it is actually talk to this mapping file, and then the mapping file will actually point it to here. That's how it is looking. I'm not going to get into the more details of it because RDMs are not widely used here, but still if you want to create clusters or something, you may want to look into that. Let me show you something here. If you do that RDM mapping, there will be definitely a lot of articles available here. So if you look here in this picture, you can see here there is how that is actually working. So it is definitely like this. This is how it is. You have the virtual machine. You create a mapping file inside your VM's working folder. That is called as a mapping file, and it will do this is the actual LUN that is outside of it. But once you do that mapping, then the VM does not need to go through here. The VM can talk to this file directly. The reads and writes are pretty much directly to the external drive. So it is not going to use any VMware or virtualization layer here. It is not a VMDK file. It uses this mapping file to do it. So anybody wants, guys, I'm not going to talk that in detail. But this article will definitely help you to understand what is RDM and how it will work. So it is pretty much like a physical disk you are presenting to the VM directly with the help of a mapping file. It is called as a mapping file. So that is how an RDM actually works. We will see that thing. So you can read that. There is also an article about MSES cluster in VMware. There is actually Yeah. This is a document. If you're really interested, see, this is, I'm not asking you to spend time, rather you spend time to read and understand about VMware and study VMware, but these are advanced documents which you may want to follow if you really want to make Microsoft clustering inside Microsoft clustering inside a VM environment. There are different combinations, there are different ways of doing it. Cluster in a box, you can create VMs, be a cluster between the same thing. You can create a Microsoft cluster between two VMs which are running on two different ESX servers. You can create a Microsoft cluster between two VMs that are in a single ESX server. See, don't think that I'm not teaching that, because these are outside the scope of this class, or way outside the scope. I don't think Microsoft or VMware has any course on this. These are something people should automate. Once you know all these things, you can do it yourself, and you have to learn and do it. It's more about advanced topics. So if you are really interested to understand, there is nothing rocket science. If you try and if you have an issue, let me know. See, this is how it is created for two VMs that are across. This is a virtual machine on node 2. This is a virtual machine on node 1. How can you make a Microsoft cluster between these two VMs? So this will act as your quorum drive or your shared storage between these VMs. So now you can create Microsoft clustering between these two VMs. So I know there are a few people here who know Microsoft clustering. I know Fanny and Sri definitely know that, but what about others? I don't know. Microsoft clustering itself is a not complicated. It's a great technology which requires a lot of knowledge to understand. That requires a lot of experience and things to understand different clustering configuration. Microsoft Clustering Service MSCS 2003 it was started with Windows 2000 NT onwards, but 2000 onwards Microsoft Clustering Service was very famous. It is being used in every large environments where they are running tier 1 application or mission critical applications are always running Microsoft clusters. Microsoft has made drastic changes in their clustering features with Windows 2008. When it comes to Windows 2008, the clustering concept itself has changed a little bit. It is now called as failover clustering. And in failover clustering itself, there are different things, quorums, you can use a file as a witness disk and file witness. There's a whole lot of things. So it's a huge topic, that itself will take probably 1 week of course is needed to finish that. But if you know what is Microsoft clustering, then you can focus on it. But these documents will definitely help you to understand what that is. But again, when it comes to RDMs, what we are talking, you don't need a Microsoft clustering. For example, in my office, we have a VM in our office that is actually used in our on-base environment. On-base, is a very document management system. It's something like Documentum. If you guys are familiar with Documentum, that's another type of document management system. On-base is another product. So we have a VM in our office which is used for on-base environments. So I'm just giving you an example. So this VM, this on-base is having high read and write always happening because a lot of files are generated, many files created here, or many documents are stored here, so thousands and thousands of people access this. So we need the highest level of read and write performance to this VM's disks. So this VM, we have a C drive, which is nothing but a VMDK. So this VM is actually the VM's working directory is inside this data store where we have a working directory. In that working directory, we have a C drive to this VM and the other files. But this VM also has a 1 terabyte D drive, which is not a VMDK, which is actually a 1 terabyte LAN presented to this ESX server. So this VM's, this disk is actually, this disk is nothing but this LAN, but it is only can be seen by this VM. If you have other VMs on this server, none of these VMs can see this LAN. Only this particular VM can see this LAN by using that so-called mapping file. It has a small mapping file, so it will establish the connection using that mapping file. And once that mapping is done, the VM will be able to talk to the storage directly through the kernel. It does not have to go through these settings. So that is what RDM means. You try to understand this. This is the whole concept behind RDM. and this is how. But when you do like this, you get almost the real performance. There is no latency or anything of that. So there is always, when you access a VMDK file, you are going through that VM kernel, so there is definitely a small impact to performance. Though VMware and Microsoft and Zen and everybody say, no, you get 10,000 IOPS and all, but definitely an RDM will be better performing than a VMDK file. But that is having its own limitations and things like that. So it is not being highly. I think I'm taking my word back. RDM was very famous and very familiar with VMware in the earlier stages from ESX 2.0 to ESX 3.5. But with the release of ESX VMFS file system 3.5X, I think it's 3.56 version onwards, VMFS has improved a lot, wherein you don't need an RDM, or meaning even if you have a VMDK and a RDM, both can get at most equal performance. Now with the help of VMFS 5, there is absolutely no need for a RDM in an environment, unless otherwise you want to create a clustering. So RDMs are today used only for clustering purpose, because in order to do clustering, you have to have a raw disk. You cannot do clustering with soft disk. You can, but that is not really supported by Microsoft. If you want to do Microsoft clustering between these two nodes, you can do that with a VMDK file, but it is not really supported. So if these two servers can see this LUN, then you can do Microsoft clustering between. What file system means? RDM is a raw device. Once you attach to this Windows server, you can format it with NTFS file system, FAT or FAT32. It is up to you. It is just like you adding a hard disk to your VM or to your desktop. Your desktop operating system is going to see this as a raw LUN, and you're going to do that. That is exactly what I'm going to do now. So I have this VM now. I have the tools installed. So you go to the edit settings here. So now you know that this ESX server currently has a LUN that is available, this LUN, that if you go to the add storage, you can see that there is a storage that is pending there. It is not converted. I'm going to use this as my RDM LUN now. I'm not going to convert this as a VMFS by doing like this. I'm not going to make it VMFS. I'm going to leave it just like that. Instead, I'm going to add that to my VM directly. So this is what I need to do. Go here, you click on the add disk, and you click on the hard disk option, click next. Here you will see an option called raw device mapping. This option will be turned on only if you have a raw device presented to your server. If your server do not have a raw device, this option will be grayed out. For example, if you go to this VMware ESX server, this one, and if I try to add a VMDK RDM to this VM, let us see this, what happens here. If I go to this edit settings of this VM, and if I say add disk and click hard disk and click next, you can see that the raw device mapping is disabled. Why that is? Because this server do not have a LUN presented there. A raw LUN is not available on this server at this point, because this server we never added to the iSCSI storage. So you have to have that LUN ready to do that. So now that I have that raw device mapping enabled, because I have a storage there, you click next, you can see that LUN, you click next, then this is the thing stored with the virtual machine. That's a mapping file it is asking actually. You can see that the mapping file, I'll show you now, click next. So when it comes to RDM, there are two compatibility levels, physical compatibility mode and virtual compatibility mode. Basically, there is a feature called snapshot, which we will learn later. If you are on physical compatibility mode, the taking a snapshot of virtual machine will not include the disk. That means snapshots are not supported on physical compatibility mode. If you want to take a snapshot of that disk, you have to have it on virtual compatibility mode. If you want to create Microsoft clusters, it is very important that you have to have the compatibility level set to physical. And I always recommend, if you are creating RDMs, I would say you go with physical compatibility mode, which will give you more performance than a virtual compatibility mode. So I'm going to use the physical compatibility mode here. Click next, next, and finish. Now you can see that I added that thing. You can see that it comes as a mapped raw LUN. You click finish. Now it is done that. Now you go to the VM again, edit settings. You can see that the third drive mapped LUN, and you can see that it is pointing to a file here. It's called as a VML file, physical LUN and data store. This is that VML file. This is that mapping file which is inside your working directory, but the actual disk is no, this is the mapping file. Sorry guys, this is the mapping file, but the actual disk is outside of this. So if you go to this VM's root directory now and open this and go to this Windows 2008, you can now see a new file which is another VMDK file. You can see there are there is a third VMDK file will come up now. 1, 2, 3, and this is the one RDN, raw device mapping. It says, but this is not the real file. This is the mapping file actually. The actual LUN is outside. This is that mapping file it created. Okay. I mean, I'm talking a little detail. If you guys want to know, that's all. There is no need to understand. So now that we have our 2008 VM ready, let me go to that VM and open it. So this is that VM. It still cannot see that LUN. So I'm going here, and you can see that it is seeing that 25 GB LUN now. See that? That is the RDM disk we just added it. So answer to Gene's question, now that it is coming as a raw device, it is just, this is nothing but a physical drive from my external storage. You can make this online. You can format this with whatever file system you want. You can initialize it. You can format it with whatever file system you want. You can do that with NTFS or other, it's only NTFS in 2008. So it supports that thing. You can do that thing. You can format it with a partition and things like that. Once you do that, no other server can use that thing because this is directly or given to that server. You understand that this is how you do that. I'm not going to do this as a storage. I just wanted to explain this. But again, if somebody asks you what is an RDM, you should be in a position to answer that. Raw device mapping, you should say that you are familiar with it. You use it for these situations, you know, in a high-end file servers, you may want to use that, or in Microsoft clustering, you may want to use that. And this is how it is done, and this is how it works. So I just wanted to show you that there is a feature like that. Yeah.
So Deepu, so no other VM can access this raw device, so just only one VM can access this?
Right now it is configured for only one VM now. If you want if you want this to be seen by other VM, then you have to do the same thing on the other VM.
Okay.
That's how Microsoft clustering works. You can share this disk with two, then it will act as a Microsoft clustering. But remember, that can be done. So, you know, I don't know, since you asked that question, let me explain that. Let us say you have a Windows server here and you have a Windows server here. And you have a LUN here or a storage here. When you attach this LUN to this Windows server put a disk signature on this storage saying that, and you will format it with VMF. Now this server say, you know what, this LUN is explicitly for me, okay, so it can only be used by this server. That is what that disk signature do. Now if you try to add this one to here, what happens is this will put a disk signature here. As soon as it do that, this server will lose the connection, because now this disk is owned by this guy. Sometimes it may not even able to attach it, because that is how Windows file system is. You know, if you present a disk to a VM or a disk to a computer, that disk is only can be seen by one server. So NTFS file system is like that. When you format it with NTFS file system, it put that disk signature and things like that. It can only be seen by one server. VMFS file system is a different file system. It is a shared file system. It can be seen by multiple servers at the same time. But NTFS file system is not like that. It is Microsoft's native file system. If you use NTFS file system and you format, it will put a disk signature and it will be dedicated for that particular computer only. So if you try to give that same LUN to somebody else, then the first server will lose connection, or sometimes even the second server say I cannot access it because it is being accessed by somebody else. So you're thinking now, how do then I do Microsoft clustering? So when you enable the Microsoft clustering feature on these two servers, then the Microsoft will deal with this disk in a different way. So if you have clustering service enabled, then you can share this disk between these two servers. It is only can be possible when you have MSCS service enabled. If you are talking about two standalone Windows servers, this is absolutely not possible. So when you're talking about Hyper-V, Hyper-V uses that clustering feature, and that is why even though Hyper-V uses NTFS file system, it is a little different from the normal NTFS file system. I'm not going to get into the details of that. I have done some research on that. NTFS file system, even though in Hyper-V it uses NTFS, but it is using a different version of NTFS as soon as you enable the feature called Hyper-V on that server and you create the cluster, it will be a whole different story. Otherwise, two standalone Windows servers cannot share a Windows disk. Okay, guys, one more minute. Let me take this call. Okay. That is, in a nutshell, Gene, your question. Okay, so that is how it is. So you have the thing. You can add that as a E or F drive or whatever it is. I'm not going to do that. You understand it is. It's not very important. Anybody has any question on this RDM thing? You understand the concept, right? Understanding that concept is enough. You don't need to do that. There is nothing much rocket science there. Anybody has a question on RDM and how it works? Do you understand the real difference there? That is the key thing. Did you understand what a VMDK file and what an RDM is? Did you understand that difference of that two concepts? Any question? Anybody? Only Satya understand. Anybody else? Okay, cool. So I'm not going to do that. So what I can do that, since I'm not going to do that, what we can do is we can add that second drive also as a iSCSI storage, because we want to build many more VMs and things. So we need more iSCSI storage. We need more shared storage. See, now you don't see that here. Why you don't see that here? Can anybody tell me? I don't see that storage here in the ESX server because it is allocated to that VM. Yes, you cannot add that as a VMFS now. So in order to do what you have to do is you have to go to the RDM, that VM, and detach that one. Otherwise, it's not going to work. So you come here and remove that, and do that whole thing. So it will now come. It is completely removed. Now you go to here and now you go to the add storage and you do this. You will see that one. Click next and go with this. Is this clear, guys? Now what I'm going to do is I'm going to show you another thing about little thing. This is not very important, but again, I have taught my old students, so I thought I will share that information. Wanted to talk about some block size information. Okay, anybody has a problem? One more thing, let me ask you. Anybody has a hard stop at 6 o'clock? Any problem with anybody if I pass little bit more time? 6:30, is that okay, or any problem, anybody? If you have a problem, let me know. Yeah, 6:30 maximum. 6:30 maximum, that's it. Okay, 6:50. All right, I mean, when we talk, we have to go that. So I'll try to stop by around that time, or let's see. So now I'm going to go here, add storage, disk file system. I'm going to add that as a VMFS file system, but this time I'm going to add it as a VMFS3 file system. When I come to VMFS3, you can see some differences here. When you come here, I'm going to call it as iSCSI _01, sorry, iSCSI _ storage _ 402. Correct? Click next. Now you are seeing something new here. You can see some block information here. VMFS5 only has one block size. It is 1 MB block size. When we talk about VMFS3, which was the old type, and again understand, ESX server or ESXi server version 4.1 and before will not understand VMFS5. So use VMFS5 only if you have ESXi 5s and above. If you have servers that are previous to that, always create VMFS with 3. If you don't use 3, other servers cannot understand that. Okay? So I'm going to talk about this here. There are certain block size information here. So it says 1 MB block size 256 GB, 2 MB block size 512 GB, 4 MB block size 124, and 8 MB 2048. The maximum size of a VMDK file you can create in a VMFS3 file system is 2 terabytes. Okay, so I'm going to talk a little bit about VMFS file system here. So what that means here is this. So let us say you have a data store like this. Let us say the total size of this data store is 1 terabyte. 1 terabyte is the total size of this data store. And you also imagine that this data store is now formatted with 1 MB block size. This is VMFS3 file system. It is formatted with 1 MB block size. So it's a 1 terabyte storage, a VMFS data store. When you format it, we call it as a data store, correct? So this is a data store. 1 terabyte is the size of it, and it is formatted with 1 MB block size. Now what is the problem? So if you look here, if you see that 1 MB block size, it's saying 256 GB. What that means is very, very important to understand when you're working in large environments. When you have 1 MB block size, you can create a VM. You know, when you, let's say you're going to create, so this is, let us assume that this is your ESX server, and you're creating a VM here. And inside this VM, you are planning to use a 500 GB VMDK file. Okay, this VMDK is going to be 500 GB. That means it is going to take 500 GB from this data store, correct? But unfortunately, since your data store is formatted with 1 MB block size, you cannot create a 500 MB VMDK file. If your file system is formatted with 1 MB block size, the maximum size of a VMDK that can be created inside that data store is only 256 GB. If you want to create a VMDK file more than 256 GB and less than 512 GB, you should have formatted it with 2 MB block size. So if you use 2 MB block size, then you can create a VMDK up to 512. If your plan is to create a VMDK up to 1 terabyte or 2 terabyte, you have to use appropriate block size. So the maximum size of a data store in a VMware environment, the maximum size of a data store you can create in one shot is 2 terabyte. You cannot create a VMFS file system more than 2 terabytes. It's not possible. Okay. So if I have a 2 terabyte LUN, I can format it with 1 MB block size, 2 MB block size, 4 MB or 8 MB block size. That's not a problem. But if I format it with 2 2 MB block size, what is the problem? Is there a problem? Anybody? That's correct. If your requirement is to create a 600 GB VMDK, you cannot do that in that case. So you have to be planned on what you are going to put. If your VMs are all going to be 40 GB, 50 GB hard drives, you can absolutely format it with 1 MB block size. But in future, if somebody come and ask, hey, Deepu, I need to create a 1 terabyte VMDK or something, even though you have 2 terabyte free space, you cannot create a 1 terabyte VMDK or a 512 terabyte, GB VMDK if it is formatted with 1 MB block size. So best practice, I would say, in that case, format everything with 8 MB. Then there is no problem, because then you can create 256 or 512 or 1 terabyte or 2 terabyte. If your block size is 8 MB, you are covered. But when it is 8 MB block size, there is going to be more white spaces and all, defragmentation and things like that. I'm not going to again get into the details of it, but if you have bigger block size, there is going to be more wastage in space, and also it may affect the performance a little bit. So you have to think about it, how you want to format your hard drives or your LAN. So that is very important. Now, sure, go ahead. Mean the block, why do you create different blocks? The block size, see, what is formatting means. So let us take that. Okay, that's a good question, that's fine. So I have a hard disk like this, and you're going to format it with NTFS file system, right? Let's take NTFS. I'm not talking VMFS here. Let's take NTFS file system. So I'm going to format this hard drive with NTFS file system. What is formatting means?
Wiping out the file allocation table or creating a file allocation table?
So it's not wiping off anyway. So it's creating file allocation table, right? It's creating tables. It's creating. So basically, when you do that, I'm not going again. Since I'm just to answer Raiden's question. So when you're doing a formatting, it creates a an index thing. It's called as a master boot record and all, and then it basically format your hard drives into smaller chunks. In Windows, you can have 64 KB block sizes, 8 KB block sizes, and in clustering, there are options where you can use some command line option to create smaller block sizes and all. So when you have bigger block sizes, also that, let me explain that. So let us say I have this hard drive, I'm going to format it with 1 MB block sizes. So when you format, basically what your operating system does is it creates these smaller blocks, and it numbers that blocks, and all that numbering and all those details are stored in an index file. And that is how it knows that where a file is stored. Each block has its own number and all. So when you access a file, your file may be sitting in multiple blocks depending on the size of your file. Correct? So let us say this is my hard drive in an NTFS file system. I have different blocks. And I'm going to put a WordPad which is 1 MB or let's say 5 MB size. So if these are all 1 MB block size, I'm going to put that Word document probably here, and here. There are, there are other situations, typically try to put the files in a contiguous spaces, but if it is already a used hard disk and all, it may be in, that is where you do defragmentation and all. Defragmentation is the process of arranging the files in contiguous file space so that it will perform fast. Now, if Raiden is clicking on that Word document, your operating system has to come, talk to the master boot record, understand from the index where all those files are, and then it will read from those locations and present you that Word file. That is how actually a disk thing actually works. So this is what it is in that block means. Now, coming to the problem, let us say I have a file that is only 10 MB in size. Sorry, 10 KB in size. You know that many of our log files, many of our VMX, the VMX file, the log files, maybe the other some of the files in a VMware environment, or in real world, in Windows world also text log files and all, they're small files. So when I have a small file, let us say 1 KB in size, that file will be placed in this area, in this particular disk. That is that file. So that file will be put in this block. Now, the operating system will never put any file inside that block. Only one file can be in that block. Now, what happens here? You are actually wasting almost 900 KB space. That is called a white space. So, bigger the block size, the chances for white space is more if your files are small. If your files are bigger in size, then you don't have to worry about it. In a VMware environment, you know that most of your files are VMDK files and all, and a VMDK file is something like a 40 GB file or maybe a 100 GB file. So there is no question about white space coming up there in lot. But still there will be some, because at the last moment it may. But when you are dealing with many small files and you are putting that small files in bigger blocks, you have a chance to create more white space, which will basically waste of storage, and also it will affect the performance and things like that. I mean, we can talk a lot about it, guys, but I think I'm going outside the scope. So answer to your question, right, and that is what that block size means. Now, you can create smaller file size, and so VMware realized that fact, and VMware with the VMFS 5, they created 1 MB block sizes. So, and there is also a sub block under that, under the cover, there is a sub block of 64 KB. That is more from a storage, Satya probably maybe, so Samrat may know that. I'm not going to get into it, even though it says 1 MB block size, but there is something called sub block sizes and all, which is more storage related thing, which is not advanced, I would say very advanced topics to cover. So I'm not going to talk about that, but in a nutshell, I hope I answered your question. Is that clear? Okay, thanks. All right, so let us move forward, guys, here. So that is what that block size means. So it is very important to understand this, but this is not there in a VMFS 5 file system. If you select VMFS 5, you see that the block size is going to be just one block size. It is not even giving you any option to select anything, because in VMFS 5 there is only one block size, and that is 1 MB block size. One more thing I wanted to tell you, you can see that the maximum file size is 2 TB. Even though you are doing this, it will only allow 1 TB. So let us just imagine a case that you have a database that has 5 TB in size. How do you put that in a VMFS file system now? The database is 5 TB in size. And you know that the maximum file size you can format is actually 2 TB. So you can create a data store only 2 TB in size.
Raw device?
You understand my question? The maximum size of a data store you can create is 2 TB, and you have to create that VMDK file inside that. Okay, I can create a 2 TB C drive, D drive for putting the database, but that's not the requirement. The requirement is to create a 5 TB thing. How do you do that? So in VMware, the maximum size of a data store can be up to 64 TB. But that is possible by using a feature called extents. So you can actually have 32 extents. So what they can do is they create a 2 TB data store, then they create another 2 TB data store, then they create another 2 TB data store, and they can club all these data stores together and create a total 6 TB. That is called as an extent. So you ask your storage administrator to give you multiple extents or multiple LANs, and then you attach all of them and make it as a single data store by using a feature called extents. So once you have that, you can create up to 64 TB. So there are certain math here. the maximum size of a data store can be 64 terabytes. The maximum size of a data store you can format by default with VMFS is 2 terabytes, but you can create extents and create a 64 terabyte volume. That is one thing. Second thing is the maximum number of extents you can use is only 32 extents. So if you really want 64 terabyte, every extent has to be 2 terabytes, and then adding all that 2 terabyte up to 32 extents, you can create 64 terabytes. If you have some of the LUNs are 1 terabyte, you will never be able to reach 64 terabyte. Does it act like 2 terabyte block while writing? I don't know what you mean by that, Arvind. Does it act like 2 terabyte block while writing? That is correct. Yes, I understand your question. Yes, when you do that, different extents, it writes on one extent and then fill the next one. It goes like that. It's not actually parallel. Not sure. Okay, I'm not sure about that. I think it writes across every extent so that you get better performance. So I'm not very sure about that. Probably I need to check. But I think it writes across all the extents at the same time, so you get a better performance when you use multiple extents. Okay. Okay. So that is extents. So you can do that. So we can do that instead of creating it as a fresh data store. I can. So now this is 22 GB. I can make this data store 50 GB. Can anybody tell me how? Just by going to the properties of this and take that, this is the extent means increase. Click on that increase button and then add this into that. Now I am creating one single LUN, but I'm using an extent. You can see now that the total capacity of this data store is going to be 49 GB because it consists of two extents. See, the 24 GB and the 25 GB together. So this is called an extent. So you can use that, and that is called as an extent. Do you understand that? I can do that. There is much more to talk about here, but I think I'm not going to spend that much time here. But the thing is, you can create extent, and once you create an extent, and when you delete that extent, the whole drive will go away. That's why I'm not going to do that. But you understand this concept of what I'm doing here. You can create extents within the drives. Anybody has any questions there? See, you understand what I'm trying to do here? I'm adding two 25. See, there is no need, but here I'm doing is I'm adding two extents and making it as one single volume instead of creating two separate. So it is possible, and if there is a need, you can definitely do that. You can also rename a data store anytime from here. That is not a problem. Working data store can be renamed on the fly. There is absolutely no problem. You can make it any name and nothing will happen. So here in this LUN currently, this is one iSCSI LUN. You go to the property, you can see that it is only having one extent. That's not an extent, that's a base drive or the master extent. But you can always add more extents to it as long as your ESX server is having other volumes there. You can add them as extents and you can create bigger volumes with the help of that. I understand your question. Can you explain a little bit more, Ray? I don't understand what is in your mind. Try to explain one more time. Correct. Correct. But the thing is, why you want to do extend? Not in this case. In this case, there is no need to do an extend. But the, okay, let us say this case itself, there is a problem. Now, I am asking you, Raiden, create a VM inside this data store. Okay? Create a VM in this data store, but I need the VMDK to be 40 GB. Can you create a 40 GB VMDK inside this 24 GB? You cannot, correct? So if you want to create a 40 GB, the only option is you have to extend this, correct? Or you ask for a new LUN with that much space. But in this particular case, I'm just giving a simple example. You can actually use an extend. But don't do that way. Typically, in that case, you add a new thing. But these extends are really come to picture or really helpful when there is a need to create a more than 2 terabyte VMD, because the maximum size of a LUN you can format with VMFS is only 2 terabyte. So if somebody is asking a 5 terabyte, then you cannot create, even though you have a 5 terabyte, your storage administrator can definitely give you a 5 terabyte LUN. But VMFS cannot format more than 2 terabytes. So you create chunks of 2 terabyte and use extends to add. That's what it is. The storage team has to provide that. From iSCSI, they have to provide more storage. The storage team has to create in iSCSI that more storage for you. You're confused? Where would you get more storage? The storage has to give from the storage, so that storage array has to come. They have to create more storage. So if they want to do that, they have to create more LUNs here. And then they will present that to your server, and now you can do extends of these together. And you can create a volume like this now that you have more storage. So the storage team has to give you the storage. This is the raw storage. Correct? Don't worry, if you don't understand, keep asking.
Deepu, I have a question.
Yep. I mean, hold on. Let me ask Raiden, what is this question? Let us fix that first. Raiden, did you understand what is your confusion here? Raiden, you there? Okay, what is your question? Did you understand this? Sure. Yeah, they have to present new LUNs to your server, then only you can extend. Otherwise, how can you extend? They have to give more space and they have to present that storage to your server, then only you can extend. If your ESX server cannot see more storage, you never can extend it. Okay? Yeah, Arvind, what's your question?
So maybe this is a little bit relevant to the Raiden's question as well. Basically, like let's say I have a, I already have a LUN that is created for 2 gig. I already have maybe 3 VMs created, and it is left with only about 100, out of 2 terabytes, I have only 100 gigs left over. But my next new LUN requires about 300 gig. So which means for the next the rest of the 200, whether I go for an extend or is it suggested that go for a completely brand new LUN?
Go for a brand new LUN will be the best option, because the company standard is to be, so in our office, as I said, all our LUNs are supposed to be 1 terabyte. So I have VMs here, I have VMs here, I have VMs here. Now there is somebody coming and asking, Deepu, I need a 500 GB LUN, VM with a 500 GB. I don't have space, so I will create a new VM and create that. Probably I may dedicate that whole data store to that VM. So extends are not used in that kind of situation. Extends are used when somebody wants to say, Deepu, I need a 3 terabyte VMD. In that case, you have to create a 1 terabyte VM. A 2 terabyte, and then you have to create another 1 terabyte, and then you make it as a single warning. That is the only time you need to do that. So you can do that the other way, but that is not recommended. I would definitely go for a new LUN in that case.
Okay. And one more question, continue to this. Let's say, like, if I'm left with the 100 gig on the old LUN, let's say, for instance, after a month, I had a new app server that needs to be created, which only requires 50 or 100 gig. So in that case, I can use this?
Yes.
Okay.
Yeah, in that case you can use it because there is space there and you can create.
Okay.
Why do you want to waste that space, right?
Yeah, that's what
Okay. So guys, that is what it is. So I'm not going to add extend also here, but let us go and add that second LUN here as a second data store because we need to create everything. I'm creating VMFS5 itself. I'm going to say it as iSCSI underscore storage underscore 02. Hello. Hello. Two storage here. Now that is the second storage. So now you have two storage. Now what if you go back to that earlier picture, basically what has happened is now these two are not these two. I think this server can also see this LUN also. Now you can see both the LUNs in this server, and that is exactly what you're seeing here now. If you want to do that on 96, you know what to do, correct? You go and add. So guys, what I need you to do is whoever wants, go to your server, try to add and do the things, you can add. But one thing I just want to tell, I think that's why I was very particularly telling, see, iSCSI is not like networking and things like that. It is little sensitive to, sensitive to what's the word? Sensitive in the sense, when you try add and remove and create and delete and all, it may malfunction and it may not work properly. So I think you all understand it. Don't try to recreate all these things. This is more than that. You understand that concept. That is what it is. You can all do that, but you can go here and see how to add it and things like that. But if you try to delete it, you know that these are only two iSCSI drives I had, and both of them are already formatted. So now when you go to the new server, which is let us say 95, all you need to do is you create the iSCSI software adapter, point it and all, and then automatically it is going to show up these two LUNs. You may not be able to add a new LUN like that because it's already formatted. So if you try to unmount or delete and all, it can create problems. So I would strongly recommend not to do that, but you can configure it with all the storage and you can create VMs here and try to see and try to read about all these storage technologies, iSCSI thing. This is what it is. So I recommend not to delete and add and all. Maybe you can try, but if it does not work, don't ask me because it can create problems. So be careful with that. Okay. One thing I just wanted to, if you are doing something, I don't have a problem. If you do something, please tell you did that. For example, the server 16 was not accessible. I don't want to tell you who it is, but server 16, somebody got into the ILO properties. They changed the ILO property from static to DHCP. And they changed the password, they tried to do something and they screwed up the whole thing, and that's why that server was not accessible all these days. So if somebody do that, oh Deepu, I accessed that server, I changed and I had a problem, just let me know so that we can have that server. That server was not available 4 days because it was, the ILO was screwed up there. So yesterday I went to the basement, I saw that, I was working with Fanny and then I fixed that problem, and that's why I told Fanny to build that server yesterday. So if you do something, that's fine. I think that is absolutely fine. You are eligible, welcome to, more than welcome to make changes, and that's the only way you can learn things. But if you do something, tell, and then we can fix it. If you don't tell it, then we don't know what the problem is. So just to give you a heads up on that. So guys, let us stop here today. Actually, I thought of finishing off NFS, but that's fine. NFS is much easier when it compared to iSCSI. Now that you understand what it is, what are the properties of VMFS, you know what is the extents, you know what is the different block sizes, you know in VMFS 3 and VMFS 5, what are the different, we talked a lot of things today. It's good that, you know, the Sunday class, you know, we are able, otherwise I may not be able to finish this topic today, but we did a lot of things. You see that different storage. So there are still 2 more servers that need storage. So if anybody wants to add, please go ahead and do that. So let us say, you know, you want to redo iSCSI on this, you have to do quite some steps. First thing you need to do is you go to this. I'm just telling, if you, my recommendation is not to do that. But if you really think that, oh no, I really want to do that, okay, fine, you can do that. But this is what you need to do. And remember, nobody is having access to iLO today onwards. I have taken the password out. So there is no, I have not sent, that's correct, Aravind, thanks for reminding me that. There is class tomorrow, next 3 days, definitely there is class next 3 days, but you all know that there is no class. So that is tomorrow is October 1st, right? So we have class Monday, Tuesday and Wednesday for sure, 8:30 p.m. EST. And with that, I wanted to install vCenter and then leave it. We will learn the clustering and all once I come back this week. We will do the clustering, and probably by 17th or 18th, I will be finishing of this class. The plan is this. So there is no class on Thursday, Friday, Saturday, and Sunday next week because I'm outside, but there is class Monday, Tuesday, and Wednesday. And by this time, we will have a vCenter, and you guys can all access it through the vCenter. But we are not going to learn the clustering and many other properties because the you know, I would say still we have not reached 50%. You know, we are still learning the VMware's concepts and storage. You know, but there's a lot more to cover here. And then next week, again Monday, Tuesday, Wednesday, and Thursday, I will be having class for sure because there is no class on Friday, Saturday. For sure, but for Sunday night, probably I might do a class on Sunday night, depending on how far we progressed. If we are not able to, because I need to finish off this by here because we have a DR test and things coming up in these weeks. So that's the plan. I have not sent a meeting invite for these classes, tomorrow's class, but everybody is there. Just remind Byron also, Ryden. Depending on now what time I'm going to come back tonight, I may be able to send the meeting invite, but definitely there is class tomorrow, and I will be sending the meeting invite either tonight or maybe tomorrow once I come back from office. So you're going to see an email probably from me only by tomorrow, 6 o'clock in the evening, but there is class tomorrow, and so I will try to send the meeting invite for these 3 days. And definitely for these 3 days, and then following week we will see. Okay. So what I wanted to tell you here was, if you want to try to, yeah, go ahead. Tomorrow is Monday, right?
Yeah, that's right.
Oh, that's correct. Good point, man. You know, actually, yeah. So that is correct because I have to take my, you know, daughter for a program tomorrow. So that is correct. So tomorrow the class will be at 9 o'clock. Okay. So we will do 9 o'clock to, please. I know it's difficult, but definitely, yeah. That is 9 to 10:30. At least 1.5 hours we can finish off NFS. I just wanted to do that for sure. But tomorrow this class, that is correct, right? And thanks for reminding that. That is 9 o'clock tomorrow. Tomorrow's class. So plan for that. Okay, 9. Yeah, I will try to be back by 9. You know, in case worst case maybe 5 minutes, but definitely 9 o'clock. That's good. Okay, thanks. So here is what I want you to do here. If let's say you want to take off all these things, you can you have to do two things here. First thing is you have to come here and delete this. When you delete something, you have to understand one thing. You are actually deleting the whole thing. It will delete, the operation will delete all the VMs and all. So that is why I really don't want, but if you want, you can do that tonight. But tomorrow onwards, guys, please don't do that. You can delete that so that it is going to reformat everything. So you can delete that LUN like this. And it takes some time. See, it's not going to do that. Why is it? It's not allowing. It is in use. Can anybody tell me why? Because this VM is currently, it is gone from here, but it didn't. It actually just did an unmount. You can mount it back actually. Mounting is different. That is like detaching and unregistering. It is something very similar to our unregistering a VM. You can actually mount it back. I think it will come up. See, this is see, it came back. But deleting is whole different story. Why is it not deleting? Is because there is a VM running on that data store. The iSCSI test is running. So if there is a VM running, it will not allow you to remove it. But probably this it will allow you to delete. Because there is no VM we created on data store 2, correct? So it is trying to remove that data store. So remember all these servers, okay, if you write and see, that is got deleted successfully because there is no VM there. If you want to remove this, you have to go to the other server, power off the VM, and then you come back and remove it. So first you remove the data stores, then you go to the storage adapters and come here and go to the properties of it, and you go here to the configure button and disable that feature. Now once you do that, you can see that you go to the storage adapters now and you click on here and you refresh it. You can see that there is no more LUNs come up here. It will go away. It will, you do a rescan here. It will not be seeing those things because you disabled that feature. It will go off, okay? But this will never go away. Once you enable this, this will going to stay there, but whether it is working or not is depending on whether it is enabled or not. Now you can see that it is disabled, so it's not going to work. So if you want to start from the scratch, remove this iSCSI port group you created, everything, you can start from the scratch. But you see that it is very sensitive, so be very careful on doing that. If 10 people try to hammer one server, it can even create even weird results, and it may end up in bigger problems. But if you want, you try it out. But I think you all understand. That's why we went through all that steps. Maybe you have to reboot the server. But remember one more thing: you do not have ILO access. So if you reboot a server and if you don't see that the server come back online, you can reboot a server from here by doing reboot. But if you reboot and if you don't come back, you will not be in a position like yesterday to go back and see whether the server is booting because you don't have access to ILO. I explicitly took your rights from the ILO because I don't want anybody to rebuild a server. Let's say, Raiden think, oh, okay, you know what, let me try to rebuild that's 96 or 16 and wanted to learn some ESX4. Probably Gene's machine will be there. You're going to format that, and I don't want that to happen because you all took pain to build all these VMs, and we don't want to do that. So you got almost 10 days or so. I think that's fine. This is something I told you in the first class itself. So keep that also in mind if you reboot. So guys, that is it. So if you want to start, you have to go back here, go to this, enable this, and you can come back to the same thing, rescan it. It will come back to the storage, and then you can add it. But as I said, now you can see the storage probably. So you can see that. So so that's the thing. So that's how it is. So just remember, nobody has access to any more ILO now, but you have access to this VM. So we have a 95. We have a 95, 96. I think there's a picture here, right? Yeah, 95, 91, 96, and 97. These are the things. You don't need to worry about ILO 16, 17, 18, and all now. No more thing. you deal with these 4 servers. These are your 4 servers you can play with. 91 and 95 is not configured with any of these. If you are doing, please send an email. I don't want 2 people to jump in at the same time and do it, but these 2 servers are ready, and these 2 servers we already configured. All right, guys, so I'm going to stop here today. Again, thanks, and I think you all understand what this is. So tomorrow there is class at 9 o'clock. I will be sending that meeting, and tomorrow we will be talking about NFS. And once that is done, the storage part is done, and then we will be looking, Tuesday we will be definitely installing the vSender. Once the vSender is installed and we add all these servers to vSender, you can all work on that, and probably you can look into certain, but vSender properties like clustering and other things, update manager, P2V migrations, vMotion, all those things we will do once I come back. Okay.
Quick question. What's the software that you use to provide iSCSI drive itself?
There are many free softwares available. I am using something called as FreeNAS.
Okay, thanks.
Yeah. And it is showing here actually. You can see that it is actually showing somewhere it was showing FreeBSD. It's actually called FreeNAS, and it's a FreeNAS 8, I think, is the latest version. It has an interface and all, but I don't want to talk about it. This is how it looks like. I'm just quickly showing this is what that FreeNAS is. It has many services. You can do a lot of things here. It has many features like iSCSI, SMTP, LDAP, FTP, CIFS, NFS. All these features, and you can see that I have NFS and iSCSI turned on, and it has many drives and things like that. I have, as I said, I have a pretty quite some big stuff is here. If you want to know more about it, we can talk about it, but I have many volumes. You can see that I have many LUNs. Some of them are used for iSCSI, some of them are used for NFS, and this is what I am using. So this is all configured on a server with many drives, and that is what I am using. So it is a good software to show all these things, and you can use that to learn it. If you want, it's a freeware you can download, but you should have a dedicated server. You should have enough of space if you want to do all these things. Okay?
Okay. Thank you, Ripu.
Thanks, guys. So good night, and we will talk tomorrow. All right? Bye. Good night.
The organizer has ended the session, and this call will be disconnected. Goodbye.